the management of ecosystems and public health. And they have been developing tools that leverage retrieval augmented generation as one of the ways of enabling LLMs to contextualize responses. Yeah, so with that, maybe Jyoti, I'll start by asking you a few questions. And I think for the participants here, they are curious to learn about your experience being a product management director at different AI companies. So perhaps you could just start by sharing with us your journey.
Yeah, so I've been in the field of AI and ML for the past 12 years. Even before AI and ML became the hype and the thing that it is today, I was part of AI and ML, and it was a very different journey back then, where we had to convince people that AI is actually important. You should try AI, versus where we are today, with everybody wanting to try AI. And as a product leader in this space, a few things that I have learned is around it's important. AI is an area where it is important for everyone who is working in it to have a strong technical understanding. Unlike software technologies like, say, Java or .NET, where as long as engineers got to know, we could get requirements from clients and engineers would go and build it. But AI is not like that for product managers anymore. AI product managers need to know architectural decisions, because they would be working with machine learning engineers and data scientists. And so you'd have to have that technical conversations. You have to know when to apply AI and when not to apply AI, because AI is not the right tool for every use case. And so knowing when to apply and when not to apply is also equally important. Understanding the various limitations is also something very important when you're designing products, because in a lab setting, a model will work great, but in a production setting, that will not work. So it's important to understand what translates from a data scientist's terminal to a production deployment. There is a lot of difference there. So all of these things mean that everybody, including product managers, need to know about AI and ML hands-on and have a strong technical knowledge. For me, as part of my journey, this is probably one of the biggest learning I have. And I have worked on products at AWS, like Deep Lens, which is a computer vision product. It was one of the world's first computer vision at the edge based product. I worked on a product called Deep Racer, which is for reinforcement learning, and Deep Composer for generative AI. And this is generative AI back in 2019, before Gen AI became a thing that it is today.
Interesting. And Deep Lens had a hardware component, right? There's a hardware component that you had to assemble.
All of them. Mm-hmm. Deep Lens, Deep Racer, all of them were hardware components, which is why it was very important for us to figure out how to get these AI ML models to run at the edge. And when I mean at the edge, is like on the device. Because the compute capacity and the specifications means that not every model can run and you don't have enough compute there.
Yeah, interesting. Yeah. So in terms of being a product management director at Netflix, what does that entail? And how do you think it can inform better AI development even within small startups?
So I think there are pros and cons everywhere. Even at Netflix, I would say that whether you're a director or whether you're a product manager or you're a engineer, I think everyone needs to have a deeper understanding of AI and ML. Our use cases are very different because it's a very different industry. My team mine is a platform team, so we cater to internal developers and machine learning scientists and engineers. And so that's the scope of the work that I am doing.
Oh, okay. And where do you see the opportunities both within and outside of Netflix when it comes to generative AI and especially LLMs?
I think there are lots of potential, not just in Netflix, just in general in the industry. There is a lot of movement happening across different pockets and areas. So one is around language, so text to text. That area has emerged very fast, like your GPTs. For example, and your Claude, Sonnets, which are no longer unimodal, they're multimodal right now. The second area is around video generation, where that's also with all models like Sora and Flux. That area is seeing a lot of value. So does image generation models like your Midjourney, or Firefly. They're also seeing a lot of improvement. And so across the board, we are seeing improvement in AI in different areas, as well as in developer productivity in terms of using AI for software development, be it code generation, writing tests, refactoring, analyzing failures for test failures. So lots of applications.
They're interesting, yeah. So I'm going to give an opportunity to some of our participants to ask any questions around AI product development and also to maybe share what they have been working on. So I'll give a chance to this team. So there's a questionnaire. You can introduce yourself and maybe also we can hear your interest or what kind of projects you work on.
Okay. My name is Raymond. I'm a machine learning and AI enthusiast. You've spoken about one needs to be very technical when it comes to machine learning. What do you think about the AI hype that is currently ongoing?
Yeah, so I think the AI hype, instead of that, I would say what can AI do really today is that it is at least significantly improved from where it was 2 years ago, or 3 years ago. Where was it? It could do recognition, it could do segmentation, it could do some of these tasks, but now they seem pretty rudimentary compared to how much AI has leaps and bounds grown from where it started. And we're in a place where we could say, let's just trust AI for everything? No, we're not there yet. So the hype, I think, is around expectation on what people think it can do. But actually, if you understand where you can apply AI to the right use cases, I think it's pretty powerful at what it can do today. And yeah, so I think the hype piece is more about expectation management, I would say.
Okay, and just a little follow-up to that. Is the hype good for the AI industry in the long term?
Hype is always a double-edged sword because there is a lot of expectation from everybody around what AI growth trajectory should look like. You have analysts, Wall Street, everybody making either a bet or against it. So that's the, but is it good for the industry? Sure. I think lots of competition is coming through, lots of new models are coming through. I also see that it's also democratizing in a way and globally uniting us with models coming in from across the world. So I'm very hopeful that we implement AI responsibly in a way that we develop these models fair, we are transparent about its capabilities, the data it was trained on. So I'm hoping that we can develop AI responsibly, but if we do that, I think there is a lot of potential in how it brings together and solves the various use cases, like for example, one of the use cases around breast cancer detection. If everybody around the world can put in the data and we can train a model, I think that would be very powerful. So yes, in the long run, it's always helpful, but again, we have to see how things are developing.
Thank you.
Yeah, thank you. Any other question from any participant?
Hi.
Hi.
My name is Njogu. I'm a women tech maker. My question is on Netflix has really benefited from recommender system. How can you advise people operating businesses within sub-Saharan Africa on how they can capitalize on the available data so that they can also benefit from these AI technologies?
Yeah, I think recommender systems as an architecture has been very popular and it's been around for quite some time. And now with the advent of RAGs and embeddings and vector databases, actually it can be even more efficient. And I would think that recommender systems is just one example, but there are a lot of these AI ML technologies. The way I would think for areas that you have mentioned is looking at AI models that are much more optimized and easier to run on smaller compute so that you can then deploy it at the edge in different terrains for different use cases. Now, if everything has to run on a server like what it does today, it takes a lot of compute. You need bandwidth. You need network connectivity, internet connection, which may not be available in all parts of Africa. And so leveraging small models, optimized models in combination with server run models might be a really good way on how you can democratize AI at scale for your different use cases. And it doesn't have to be limited to only recommender systems. It can be for other use cases, even like computer vision use cases, where your smaller model could do the filtering and immediate in-person or like in that moment detection, while your server models could then later do like the processing and adding it to the training data and things like that.
Wonderful.
Yeah, I know it's late here in LA and you have a hard stop here. So thank you very much.
Thank you, Jeffrey, and it was really nice seeing you after a long time.
Yes, yeah, good to see you, and yeah, have a good night.
Yeah, thank you.
Yeah,
Bye,
thank you.
everyone.
To take any questions. I'll be walking around to just help with anything. Yeah.
Together, University of Michigan, especially from the computer science and engineering department. And that is doing really amazing work on airlines from different aspects, including evaluation of multi-agent systems and studying biases that arise in these systems. So thank you, Angela. I'll hand over to you.
Hi everyone. Yeah, today I'm going to be talking. Today I'm. Hello. Hello. Yeah. Today I'm going to be talking about LLM-based agents and evaluation. Yeah, I'm a second-year PhD candidate, and I'm advised by Dr. Radha Mihilsha. Some things about my research interests. I'm very much interested in understanding LLM behavior, taking inspiration from existing cognitive science and social psychology studies. I'm also interested in societal implications of LLMs, analyzing biases, misinformation, propagation in LLMs, and potential mitigation techniques. I'm interested in agentic LLMs, LLM-LLM interaction, and also human-LLM interaction. And yeah, also evaluation of different NLP methods. So here's an overview of my talk. So I'm going to be introducing you guys to LLM-based agents, and then talking about some applications of these agents and how to evaluate LLM agents, and finally some demo on these LLM agents. So yeah, starting with agent. Because it has been agent has been in our society since a long time before LLMs came into being. So the philosophical definition of agent is something that possesses desires, beliefs, intentions, and the ability to act, and has some form of autonomy. So the survival of the fittest theory, if an individual wants to survive in the external environment, one must adapt to surroundings efficiently. So yeah, so the philosophical definition of an agent involves it having some form of autonomy and also being adaptable to different scenarios. An AI agent is a concretization of the philosophical concept of an agent. So there's a surrounding, and the agent can perceive these surroundings, make decisions based on what's provided as an input, and then take actions and provide a response to the user. And yeah, so AI agents have been used in traditional AI since a long time, before LLMs started. So LLM-based agents are newer than traditional AI agents. So here is a quick comparison of traditional AI agents and LLM-based agents. So the knowledge source for traditional agents were mostly pre-programmed or domain-specific. However, LLM-based agents learn from diverse and large-scale data, since they're pre-trained on a lot of data. The reasoning capabilities of traditional AI agents are more symbolic and rule-based, whereas LLMs use more probabilistic neural reasoning and more kind of implicit in their sense. Adaptability, traditional AI agents are very much limited to predefined behaviors. They were more specific, like domain-specific. However, LLM-based agents are like very dynamic, and they can be adapted to a very number of tasks. Interaction-wise, traditional agents were mostly mechanical. LLMs are context-aware, more human-like, and we can converse with them. And finally, in the aspect of environment, traditional agents are more, physical, or like they are kind of simulations in real spaces. However, LLMs are more textual or conversational, but it also can be extended to physical using embodiment, and also use tools for different actions. So why are LLMs suitable as agents? Because it showcases a lot of different capabilities, and I can go in detail for very quick reasons as to why. So autonomy, because LLMs can generate human-like text. They can engage in conversation and perform tasks without us, guiding them step by step. So we can ask a very high-level query, and LLMs can reason within themselves and come up with an answer without us giving, all these step-by-step instructions. So they show some form of autonomy in that sense. They're also reactive. They can respond to changing requests through text, and also can expand their perceptual space using multimodal fusion, including not just text, but images and speech, and also expand their action space using tools and embodiment. They show some form of proactiveness as well. They have a goal-oriented action. They take initiatives to understanding why a query is being asked and how to answer that. They're also good at reasoning in several tasks and goal reformulation, where sometimes we do not query the agents or like LLMs in a very clear manner, but we find a lot of the times LLMs do understand what we are wanting to ask. They form the goal based on past experiences. And finally, LLMs do show some form of social ability. There is also multi-agent interactions among LLMs, where we see that LLMs do show like emergent social behaviors like humans do in a lot of aspects. So all these aspects make LLMs suitable as agents. So the general framework of an agent consists of the brain, which is like the central controller, requires memorizing, thinking, decision-making, and perception, which is basically interpreting different form of inputs that's coming into it. So the most traditional sense, LLMs take text, but we also have multimodal form of inputs nowadays. You have image, we have like documents, and like also like a lot of sometimes speech, like voice recordings as well. So it can perceive all these different types of inputs. And also action. LLMs can execute these tasks and output in the most generic sense as texts. Also can use appropriate tools to output images or other forms of modes, and also embodied action in the physical realm. So as you can see here, this is an older paper from 2024, I think, but you can see like 2021, this was what was done in the agentic space. 2022, but it skyrocketed kind of in 2023. In just a few months, there was a lot of research going on in the agent space. So it's still going on, so it has a lot of potential. Some agent applications include like a single agent performing tasks for us. There also can be agent-agent interaction, where you can have multiple agents collaborating or debating to perform like a task and achieve a particular consensus. And also there can be like agent-human interactions. So for single agent, it can be either task-oriented, like performing day-to-day life tasks. It can be innovation-oriented or life-cycle-oriented. So in the task-oriented scenario, we have like web scenario or like live scenario. So web navigation problems like filling out forms or like online shopping, sending emails, etc. These are some web scenarios. So OpenAI Operator, I think, also is a newer tool to do things for you in the browser that you can like ask it to book a trip, etc. So yeah, this is the web scenario of how a single agent task-oriented performance can be done. There's also a live scenario where there are daily household chores, and you can ask agents to perform some tasks, and they would be using world knowledge embedded in the training data, and this would be helpful for the real-life interaction with humans. Innovation-oriented, it's like using agents to build innovative techniques for solving certain problems. These are very much intellectually demanding because they are very domain specific, and this can lead to a lot of complexity. Also, there's a lack of training data for specific domains like different science fields, so it's one of the issues that LLMs can face in innovation-oriented. So tools can really help with these scenarios. And then there's life cycle oriented, like how we discussed about the philosophical definition of an agent, where it has some adaptability to different environments. So in the life cycle oriented, agents can continuously explore, develop new skills, and maintain a long-term life in an open, unknown world. So Voyager was one of the first LLM-based embodied lifelong learning in Minecraft, which is a game where we have to continuously explore and discover as many tools as possible in a newer world. So as you can see here in the orange line, Voyager did really well in finding as many tools as possible in Minecraft over different iterations. So yeah, so this is one example of agents in the lifecycle oriented sense. Then we have multi-agent, where agents interact among each other. So single agents are isolated agents. Multi-agents are where agents interact among themselves, and this is most of my research is also based on multi-agent interactions. It's inspired from the Society of Mind by Marvin Minsky, also by the theory of intelligence, which says that intelligence emerges from the interaction of many smaller agents with specific functions. So two typical types of how multi-agent interactions are done. There's cooperative, and also there's adversarial. So for cooperative, it's basically what the term suggests. Agents collaborate to achieve a particular, to achieve a solution for a task. So it can be ordered where, different agents so one more thing to note is that when there's multi-agent interactions, we have agents with certain personas assigned. So agent can take on a persona of a manager, a designer, or any other demographic. For example, so whatever interaction scenario we provide them, they take on these personas and kind of interact as if they are those people. And then we kind of make them interact maybe in an ordered way where they follow a special sequence as to how they would provide generations. Or they may be disordered, where each agent is free to express their perspectives openly. And this also is very much related to the real world, where we see hackathons, for example, people collaborate and arrive at a solution, which may be which is much probably better than what you would arrive when you are working as a single person. So yeah, so this would lead to synergistic complementarity as to how you arrive at a solution. One example, this is one of my works on understanding how we can use cooperative engagement among models for culture-aware image captioning. So for this, I did not use LLMs, but I used large multimodal models, so which are image and text models. I used Lava 13b, and I used it to act as agents belonging to different cultures. So our question was, provided an image, different people from different cultures can perceive it differently, and it may not be the same for all cultures, but since large models, large AI models, are mostly trained on Western-centric data, it can lead to more Western-centric behavior or outputs. So how can we make these models more culturally aware so that they can actually understand different cultures and lead to outputs that are aware of different cultures? So we had different agents performing the roles of different cultures, and we also had a moderator agent to generate questions for a particular image that are culturally more aware, and then there's a summarizer agent which would summarize the interaction of all these agents. Then we finally evaluate our framework with different evaluation matrix for multimodal evaluation, like alignment completeness. We also have a score called cultural info, where we look at how many cultural words are present in each of these generations. And we find that, so our model is called Mosaic, so we find that Mosaic does really well in terms of cultural info, so multi-agent framework can really help achieve a better performance in terms of image captioning in this setup, and also does well in other matrix as well, in the generic matrix, which are not culture specific. So this can be really helpful if we want to, we can leverage this for making humans and also LLMs more culturally aware. Then moving on to the different aspect of multi-agent interaction, there's adversarial interaction, where you can have agents debate or compete with each other and arrive at a solution. So as you can see here, there's a critique agent where they are asking why this is good and why it may be a bad idea, and then there's another agent which would be providing convincing arguments for the same. So this can be really helpful as well, because agents would dynamically change their strategies, and also it's at the end the most advantageous or rational actions are chosen. So yeah, so this is an example of adversarial interaction. And this is something I used for one of my works on understanding misinformation among different demographics. So misinformation perception and its spread is a lot in the society right now. Also, it can vary based on the demographics. So for example, there was a study which found that Hispanic people are more susceptible to misinformation regarding COVID-19. So how can we actually solve that? And try to solve that, because it's a very big issue. Also, there is an issue of echo chambers in misinformation, where you can there's a trust factor coming in. So you trust information coming from the same demographic more often than people who do not belong to the same demographic as you. So if someone from your close circle share a piece of information that may be misinformation, you have a higher tendency to share it to other people. So that's like an echo chamber formation. So we try to simulate LLMs, which are demographic aware. So here we initialize LLMs at different demographic personas to understand these effects. So we have like homogeneous and heterogeneous groups. So homogeneous group is a group which consists of people from the same demographic. So we look at like gender demographics, female, male, and also age demographics, young and older people. And then we form these different frameworks where we have different like homogeneous and heterogeneous groups, and they kind of then interact. And then it continues on for some time, and then they give their final output. So what we do in our setup is that we give a piece of information which can be true or false, and then we ask each of these agents if they believe the information is true or false. Then they kind of interact among different LLMs, and finally give the final responses after interaction. So our hypothesis is that homogeneous groups will increase the spread of misinformation. And how we determine that is we use the correctness score, as is correctness score is the number of times an agent correctly identifies if the information is true or false. And we do this for like the first responses before interaction and last responses after interaction. And then we calculate the differences. So if correctness rate is like higher, positive, we would say like final responses led to better understanding of misinformation. So we do this for different demographic groups, and we do this for heterogeneous and homogeneous groups. We have del CR here, which is the difference in rates for final and initial responses. And we do see like for heterogeneous groups, it's often almost always higher in most cases just than the female demographic. And we see homogeneous groups do not lead to a lot of like increase in these, correctness rates. So yeah, so having like more heterogeneous, which is like more adversarial form of interaction, where you have people from different groups, agents from different groups having different thought processes, can actually help reduce the misinformation spread. Some challenges of multi-agent are that even though they are very helpful, they can be computationally expensive, which can lead to higher overhead. And also, since this involves interaction among multiple rounds, so it may lead to like, since LLMs do have limited context size, so in like storing all of them can be an issue. So for this, a lot of different techniques are used, like in terms of memory, like how humans remember the most recent memory, or like most important memory that they really want to store, like the most important thing for them. So a lot of the times, those kind of techniques are used to help with the context storage issue. And one other challenge is that they can arrive like at an incorrect consensus. Finally, there is human-agent interaction as well, where you have like an instructor-executor paradigm, where the human would be instructing and the agent would be answering or like the questions. And also there's equal partnership, which is often used in a lot of like mental health studies involving NLP and LLMs, that they would be like equal partnership where humans will be sharing something, agents similarly, and then it goes on. So yeah, that's a human-agent interaction. Then we have move on to the last, the evaluation part of the LLM-based agents. So there are 4 dimensions, which are very important. There can be more, but these are, I think, the most important 4 dimensions. One's utility, sociability in terms of LLMs, and values, and being able to continually evolve. So utility basically refers to success rates in terms of task completion. So this can be like evaluating your models or frameworks in different data sets or benchmarks, more like foundational capabilities. And there's Agent Bench, which is a very systematic benchmark to assess LLM's task completion capabilities, and it aggregates challenges from a lot of different diverse scenarios. So there are like 8 distinct environments, and it assesses these agents in terms of performance in all of these environments. There's also sociability in LLMs, understanding how they communicate in terms of proficiency in language and their cooperation and negotiation abilities, their role-playing abilities, and how close they are to different personas. So that's that aspect. The third aspect is values, which is very much highly researched area right now in NLP, to align models to different human values, since these values can change based on demographics, cultures, contexts, and also like on an individual level. So how do we align models to different values? There are 3 H's that are important, like harmlessness, helpfulness, and honesty. And it's it's like a trade-off between harmlessness and helpfulness, because most of the times, if a user asks a question, the agent wants to be helpful, but also wants to be harmless. So sometimes when a harmful query is being asked, the agent would not be helpful. So you often have to have your model in a trade-off. So yeah, that's one way of evaluating LLM-based agents based on human societal values. So I'll quickly go through one of my works on implicit biases in evaluating multi-agent LLMs in terms of implicit bias. It's a low research area, I would say, in LLMs, or like in NLP itself, because implicit biases don't really occur in how very explicitly, like the name suggests. So you have certain stereotypes that you assign to, certain genders, and it often occurs without you actually acknowledging it, and it just visible in your actions. So yeah, so that's something like implicit biases. And then multi-agent LLM interactions can actually help us reveal these implicit biases through interactions among the agents. So the motivation for this is that a lot of the times, so I took a lot of, I did a lot of studies and I went through a lot of studies in psychology and social sciences as to where implicit biases can actually occur in real lives. And it can occur in different fields like politics, law, offices, education, schools, etc. And it's often in our sense that males are more associated with leadership, technical, and physically strenuous roles, and females are mostly associated with organizational, planning, creative, family-oriented roles, and that's something we have been seeing in our daily lives, and we tend to associate these genders to these roles. And this can also lead to harms later on if not addressed beforehand. So what we do is we try to create scenarios for our multi-agent interactions, and we have different tasks associated and characters. So here is a scenario from law. So prepare a legal team for a challenging case at a law firm, and we have different tasks like formulate the main legal strategies, cross-examine the witnesses, organize the case files, and schedule meetings with the clients. So from previous studies on psychology and social sciences, we try to create tasks to achieve that particular goal based on if they are stereotypically male or stereotypically female tasks. So here, organization and scheduling and planning are more stereotypically female tasks. So similarly, we create the scenarios and tasks, also characters, and we kind of feed this into the multi-agent framework. So you have different agents taking on different characters, so Lisa, Anna, Michael, and Robert, and you have different tasks associated, and we ask the multi-agent, different agents to kind of assign these tasks among themselves to achieve a particular goal. And we use this framework where we have initial responses of agents where they assign tasks among themselves and they don't look at each other's messages. But then they go into the discussion round where they kind of see what each of them say and then try to convince each other. And also later on we ask them to be open, how it goes on in normal group discussion scenarios. And then finally we ask them to give their last responses. Again, if they change it. So we look at initial responses and last responses and kind of see how many times do these models actually assign stereotypically male or female roles to the agents. So we have a bias score between -1 to 1. So if it's positive, it means the assignment is stereotypically how it is in the society. So we do see the scores are positive for most, all models. So, and we also see that GPT-4 has a higher, larger models exhibit higher biases. We also do this with Mistral, I guess, smaller Mistral 7B, and then we see lower biases in comparison to GPT. So we do see it also increases after interaction, leading to increase in biases with multi-agents. So that's one thing we see, that with multi-agent frameworks, these if there are issues with a single agent, it kind of amplifies in the later stages. So we also work on mitigation with self-reflection and fine-tuning, and yeah, it works for smaller models and in comparison to GPT-4. With GPT-4, it just makes it opposite. It's anti-stereotypical. So we want the models to be more neutral, as it not follow any stereotypical assignments. So that's what we find with this. And finally, with evaluation of LLM agents, we also want the agents to continually evolve and have some form of autonomous behavior in terms of how they require resources, and also we want to reduce human intervention, but we also have to be very sure of how much autonomy we want to provide to the agents, because it can lead to other concerns. One quick example of how we can use agents in RAG, it can be helpful. It's like, because traditional systems may not have like really better context awareness. So agents can actually sometimes help with better contextual integration, because they have memory and they have like planning, so it can lead to better accuracies at times. So there are different network structures like prompt chaining, routing, parallelization, where you can have like different agents looking at different tasks. For example, if you have like data coming on from different sources in different structures, like there's SQL or unstructured data and different sources that it comes from, so you have different agents for special tasks, and you can like route them based on the query that's given to you. And when not to use agentic RAG is when you have like simple queries, or you have limited data, or high development cost constraints and real-time response needs, because these systems often tend to be sometimes slow because you have like multiple agents working on it. These are some resources, and thank you so much. Do we have time for like 5 minutes for the demo? Okay. Then you pass it to the tool. So I call search here, like I have search here, and then you pass it to the tools that you're going to be using later with your model. Then I'm using Mistral model, and with that I'm using langgraph.prebuild to import create React agent function, which takes in model and tools. And then you can kind of invoke it to ask questions. And here, it also knows when to use the tool. So where you're asking questions like, hi, it won't be invoking the tool. However, when you're asking questions like, what's the weather in Nairobi right now, it will invoke the tool here, as you can see. And then when you're working with like a longer problem, which may need like streaming messages as you go on with agent responses, you can also do that using this. And then also one important thing to note is that agents in a lot of frameworks are stateless. That is, they do not have any memory. They do not remember previous interactions, so you can pass a checkpointer to give it memory. And you can pass a thread ID to make the agent remember where you can pass the, where to continue the conversation from. So you just call memory saver here, and then you have a agent, then you have like checkpointer memory here called, and then you just give a random thread ID. And in the configuration, then with streaming messages, I'm asking like, hi, I'm Angana. And the model replies, nice to meet you, Angana, how are you doing today? And then since I called the config here with the memory and the thread ID, you can ask the question if it's remembering the context, so what's my name? And the agent will be like, you told me your name is Angana. So that's how it remembers. And if you want a new conversation, you can just change the thread ID. And these thread IDs are like, you can just define yourself. It's random. Also, like, it can be used to create, like, this is a tool that we use heavily, like, very much. It's, you can use it directly. You can also build your custom tools. So I'm going to be using, like, Hugging Face here, like a model from Hugging Face. And I will use the wrapper for Hugging Face for LangChain. So you can have, like, models from Hugging Face called, and you can use this wrapper to use it with LangChain. So I'm using this tool to basically ask the model, to like run a Python script based on the questions that given. So it's like very custom, and it can be really helpful if you need it for like your own custom purposes. Then I have a text generation pipeline, like how we do in Hugging Face, I'm calling the llama 3.21 billion instruct, and the max length and all the necessary parameters for calling the pipeline, like the model. And then I have this wrapper for LangChain LLM, where I'm taking the pipeline and the model ID. And I also have the tools as defined there. And I kind of initialize the tool with the LangChain function. I give verbose true. I want to see what the log execution details are. Then I can use for like different questions, like what is the square root of 256? And since I'm asking the model to like use Python to solve this, it solves like here, as you can see, like the log comes out. So question, what is the square root of 256? the thought, I should first try to find the square root, import math, which is a library in Python. Math is a module in Python, and square root function, and then kind of use the whole thing to find the square root of 256. So yeah, so you can, this is a very simple example of how you can use custom tools, but it's really helpful if you want to do it for purposes that are not, tools aren't available for you. So yeah, so I think that is it for me. Thank you so much, and sorry for running over time. Yeah.
Hi, thanks for the presentation. Quick question on the implicit biases. So you mentioned that, I'm trying to remember what you said. So the work that you've done, the goal is to make it neutral, where it's not very, to kind of reduce the stereotypes, but then not making it lean too much on this other side. So I'm just wondering, how does that limit the creativity and other aspects of the language model? So I'm just wondering, how do we have an example of, in the slides you mentioned that the LLM, the traditional agents actually are good when it comes to domain-specific tasks. Do we have LLM-based agents that have almost kind of narrowed that gap between the domain-specific rule-based agents, or we're still kind of working towards that?
Thank you for your question. I can answer the second one first because I open. For LLM-based agents, you can have more specific agents as well with fine-tuning or using reinforcement learning. Should I use this? Okay. For aligning the agents more with the tasks that you want, so you can have that as well. But the more broad LLM-based agents are actually, because they are trained on a whole lot of data, so yeah, they can be used for various general purpose LLMs that you see in the current world. Yes, traditional AI agents can be really good, but the issue with that is sometimes very much rule-based, because you have to define the rules beforehand, and you may not, consider all the corner cases in that case. So yeah, so I think there's a trade-off between LLM-based and traditional AI agents, but LLM agents also can, be more domain-specific based on the, data that you have, and make it more fine-tuned to a particular task. Yeah. Yeah. Yeah, I think so, yeah. One problem with LLMs is that, in terms of the data that it's fed with the pre-training, there's a lot of other implications that arrive, with more critical fields like medicine and drugs and everything. So there are some issues which we may arrive at, but I think it can really arrive be very close to the traditional agents in terms of because it's better at context and better at most of the other things. So I think we can definitely arrive at it. And I think we can learn more from the talk later today in terms of drug discovery. Yeah. Yeah. For your second question on implicit biases, let me just go to the slide. Yeah, so yeah, we were on the mitigation end, we were trying to mitigate the models using self-reflection and fine-tuning, and both of them really helped. But we did not actually look at the generic capabilities later on after fine-tuning. Often it is seen that when the model is fine-tuned for a specific purpose, models lose their generic capabilities in other tasks. So that's something we need to work on. I think one big issue with biases is that how can we scale it to bigger models and actually see those changes in models that we use today, like ChatGPT or other chat models that are open source. How can we scale these mitigation methods to actually work there? So maybe using adapters or something like that, so can help. I think it's a very difficult problem, but yeah, I think, yeah, so yeah, that's it. Yeah. Yeah.
And it would be interesting to extend that to another region where,
Right.
In Nairobi, for example,
Yeah.
in another place, and see what the similarity evaluation, if you've looked into where humans can also
Thank you so much. For the first question, I think in terms of demographic aware LLMs, right? So we did I didn't go through the study in detail, so I was looking at more persuasion capabilities and looking at how it can affect interaction in models. And I don't have it with me right now, but we found model GPT 3.5 Turbo and humans in terms of misinformation susceptibility, the correctness rate that we define, it has a 0.4 correlation, which is decent, not really high, but I think it has a potential. So what we do for our models is so we did this in Michigan itself. So we had human parts, from our lab. There were annotators doing that, and we had male, female, rural, urban, and younger and older people, and older people as well. So we had those data, and then we tried to for demographic aware models, one simple implementation that we did was just having in the prompt, for example, assume you were this and you have these disease traits and stuff like that. We did not try fine-tuning. I did fine-tuning for the culture-aware image captioning thing that I mentioned. So fine-tuning does help there. But I feel fine-tuning also requires a lot of compute. So if we can achieve that same performance with just prompting can be really helpful. And I think with demographic aware models, we can also have human interventions, as you suggested. I haven't really looked at how humans can intervene, but there's work on misinformation where you can see how LLM persuasion can kind of help humans get swayed in the right direction. LLMs are, there's a news provided, and LLMs would be sharing, okay, this news seems to be true or false based on this. So there we provide the LLMs with original answers if information is true or false, and they provide reasonings, and it can really help humans to get to the right path. So I think long-term implications of this can be using it in social media in some way, and kind of having more human interventions in terms of if the human is sure if a particular piece of information is true or false, it can kind of intervene. But I haven't worked on it myself personally, but yeah, it's a really interesting field. Thank you.
Any more questions?
Yeah, sure.
I think a lot of the challenges of using LLMs in different modes, text, voice, image, and video come into play depending on the context, and as you say, the values that an LLM learns from. And I'm curious if you've also, on the image captioning, it would be interesting to actually extend this work to images that are contextual to a certain region, to see how well that does, and then what interventions you might take to make them more aware of the values of that context.
Yeah, I think that's very interesting, having a more contextually aware image, right? Yeah, I think with the models which are multimodal, I think there are a lot of improvements, and I don't do a lot of multimodal work, but I think the biggest issue is regarding the embeddings, right? Because texts have much smaller embeddings in regards to images, which have much bigger embeddings, and how do the same model can process it? So yeah, I think having more culturally aware images. So in our study, we did try to have some data sets which are more culturally aware, GDVCR and CVQA. So that's cultural VQA. So it has images from different countries. So for our work, we had India, China, and Romania. We were just 3 authors in the work from different countries, so we had that. And it does help, I think, with more culture-aware questions. There are also issues in terms of how images are interpreted, and how different images can, how can there be different images for one same, question? A bathroom can look different in Asia, in different countries, versus the US. So I think making models more aware culturally, I think, is definitely important, and having that context in the image is important. Thank you. Yeah.
Thank you so much, Anna. That was wonderful. Let's give a round of applause. Good morning, everyone. Good morning, guys.
Because our table has been overtaken by our mentors. Thank you very much. But we're happy to announce that we have good progress with LangChain and changed the vector DB to files, which I've actually tried right now, and it's working pretty well. So that's what we has run well as executed. According to our measures of success, we wanted to, play around with this and really understand what works best and what works, you should tweak this thing. Personally, I've worked on this which I like. My fellow teammates worked on LangChain, which we love, so we want to sit down and see, like the agents, we were monitoring agents, so now see which one we pick and run into.
Awesome. Thank you so much. Let's hear from group 2.
So for our group, for our team, we did an issue yesterday where our model will try each data from figures to big files, and that's what we want to operate on, and at least we have some logics going. The one issue we have is no benchmarking of different environments together. And when we try to move from the chat to equipment, we realize that some of the libraries don't get installed because of the environment information. And then we go to the
Right, you the same team, yeah? Okay, this is team 4 was doing.
Difficulty, even tweaking the vanilla. This morning we've had a breakthrough, but the problem is that we are not having the right score at the moment. So so we are not getting the right scores. What I mean is we are not getting impressive scores, but we're working on that. Thank you.
So far, the progress we're having on task 1 is that we've been able to implement the basic functionalities of RAG. So we just want to add on top, like chaining the other models, like vision LLMs, also to see if it can go through, like the PDFs we are having, most of the LLMs and the embedding models, they can work on the text part. But when it comes to the images, the graphs, those ones, it is performing very poorly. So that is what we are trying to perfect on and see if it will achieve something.
What are some of the approaches you have tried with data which is in images or tables? Yeah, the also mentors here who can also give guidance.
So far, we were using a framework called Pali, but now we are running, when we run it, with some simple, let's say a few pages PDF, it's working. But now when we give it maybe 20 pages, it is failing because of insufficient memory. So it's not a viable solution. Yeah.
Right. Thank you.
So there's a text. One, on memory, you can chunk the PDF. So before you use the PDF, split it into chunks based on categories, and you can use an LLM and then validate whether it makes sense. So assuming you even had a 200-page PDF, you need to split that into smaller chunks. And then now in those chunks, maybe there's text, as you say, there's charts, maybe tabular data, and images. So in the preprocessing step, you can also, some initial ideas I'm thinking about is transform that data. So go through the chunk and transform that data. You can use vision models to kind of extract the data back into text so that it's not too computationally heavy at that point, so that all your data is represented in one form. Of course, we know right now that models work better with text data, which is unfortunate. And so, like Angana talked about image captioning. So imagine just extracting all the data you can from an image and then now replace that image with that information about it. And then when you're returning the response, maybe you want to return it as an image with text, or you want to return it as just text. Same for tabular data. Tabular data might be easier than the images.
Okay, just speaking on that, when you speak of images and...
So maybe one thought is, if the images lack captions, extract information from it and compare. You can also compare different modes in terms of the information it extracts from an image, which one is doing the best, and then you pick the one that is doing the best. So that's what I'd recommend for now.
Okay.
Thank you so much, Mercy.
Good. We were able to extract text, text from images using OCR. The challenge we are facing is with dependencies. I don't know if it's an issue with DeepNote, because well, I run my code, it's working. I run it some other time, it's not working. Some dependencies off. Then someone in my team says when they try installing a package, it's already installed, yet they are not installed it. So I don't know if it's an issue with our codes or it's an issue with DeepNote. Yeah.
Yeah, we can look into that. Maybe during the...
Isn't what we wanted, so we are trying to adjust it. But as the leader said, we are still good.
Okay, thank you so much. Afternoon, so that you can get started on the next task. So after this, we shall have a short break. And then when we come back...
You said you work with fintechs, right? So that's a lot of tabular data, CSVs, Excels and stuff. And then I don't know who works with images or stuff. So LLMs, why does the nature of the data matter? Because I thought it shouldn't. They should be able to process any kind of data. Or what's the difference when you're working with that? Excel, CSVs and stuff compared to PDFs, images, like?
Well, so it's just the way the data is kind of organized and viewed. So one big difference between us as people and LLMs is we have like eyes and we can look at an image and kind of extract information. And that's way harder for like an AI or code to basically do, is to extract information directly from an image. But what code is really good at, better than us at, is looking at structured data like a CSV or something like that and pulling information directly from that. And actually, an LLM, if you just hand it a CSV file with thousands and thousands of rows of data, it'll typically do a pretty bad job at extracting a specific metric from that big CSV file. But what you can get it to do is write code that can access an exact value that you want in a CSV or in a SQL database or something like that. So it's a little different, where it's not looking in the CSV and looking for a value. It might be writing a little bit of a Python script that knows how to access the file.
Yeah.
Do much better with the CSV because it's able to write that code and it'll get an exact answer. With a PDF, it'll struggle a lot more because it can't write the code to extract a specific piece of information from it.
Okay. Okay.
So, yeah, hopefully that.
kama unaona vile nilikuwa nakwambia. Hi, Mom. Good, and you? Yes. Happy to see you.
Yeah.
Oh, nilikuwa nasema tu. Unaona kama nilikuwa nikwambia shoot D na R. Per editor hatajua difference. The same thing.
From the Nature Conservancy, so TNC. She's going to be talking a bit about their Water Fund program, and this is one of the use cases tomorrow that the tools will be judged using. So you'll be receiving a couple of project design documents and monitoring and evaluation documents for these Water Fund projects, and then the task will be how well your RAG models are able to contextualize that information and and provide useful outputs. So with that being said, let me hand over.
Thank you. Hi, everyone. Hello. Just a brief introduction. My name is Akshi. I'm based at the Nature Conservancy in Nairobi. Our office is in Karen. Gong Road is no joke. So I'm working within the Water Funds team. We're under the Resilient Watersheds. I'm the Source Water Protection Partnership Specialist. And source water, for those who are unaware, is basically when rivers flow into cities and provide water to the cities, the area where the source is, whether it's Mount Kenya, whether it's Aberdare, that is the catchment area that we like to focus on. Let me get started. So these are shocking stats. I hope everyone in this room is no stranger to the fact that we are in a climate crisis. I think the impact of that climate crisis is beyond even what we know or our knowledge on it. Our area in the water funds is focused, as I mentioned, on the catchment area, the water quality and water supply going to our downstream users. So whether you're looking at the farmers at the top, right next to the mountains, or you're looking at the cities like Eldoret, Mombasa, Nairobi, for example, and how this water supply is going into these increasingly urbanized populations. Now, what is a water fund? In trying not to use too much floozy language, a water fund is basically a governance structure. What our team found about 10 years ago, and have tried to scale it since, is the idea that we need multiple partnerships from all people within the region or within the catchment. So in Kenya, that includes your county government, if there's an NGO in the area, if there's a private funding body focused in the area. These are how we consolidate these groups, and we turn them and unite them as our stakeholders. All of these people are involved in either provision of water in these areas, or the supply, or are users of the water. Our goal is basically to use the idea of a common goal, which is improve water quality and water supply, and create nature-based solutions to address these. TNC loves nature-based solutions. Nature-based solutions are basically the focus of using nature and natural resource to regovern or utilize the land to become stronger. The idea, we love this image. The idea here is before and after applying nature-based solutions, NBS. As you can see above, nature-based solutions cut across it, whether you are, as I mentioned, at the catchment area, as you live along the river and access that water of the river, or as a downstream user, including cities where they're pulling in water for whatever utilization they need. The idea is to use nature-based solutions to improve the health of the water, improve the quality, reduce pollution through several interventions. As you can see, there are several opportunities to intervene, whether it's focusing on farmers, focusing on building a dam, focusing on water quality through reinforcement provisions, etc. Water funds started and have their most successful or most operationalized water fund called the Upper Tana Water Fund in Kenya. Upper Tana, as many of you may know, is the major river flowing into Nairobi, and it comes from the Aberdares. Since then, about 11 years ago, a water fund model has now scaled across Africa. We have seen that whether it's each region, each country, each catchment faces their own unique issues and unique water supply issues. We continue to work with partners across the board to provide real-life experience, knowledge sharing, and hand-holding in designing, implementing, and running a water fund. The idea of a water fund, or the success of a water fund, is when they become their own operational model and are now able to run based on user payment or funding from a charitable trust, but operationalized. We also call, this map is useful to see the use of partnerships. Water funds are not a TNC-owned, TNC-run thing. Water funds are run with the help of the government of Kenya, for example. In Mzima Springs towards Kwale, it's run in partnership with the Maasai Wilderness Trust, etc. This is an example of the type of data we currently collect and what our idea of success or our metrics of success are. I mentioned that Upper Tana is our most operationalized and has now turned from a water fund to a charitable trust managed by a board of governors. And all water funds' goal is to get to this stage, all 17 and any future ones coming. And this is just Africa. We also operate in Latin America. We look at different interventions. This is a good example of it, whether we're providing fruit tree seedlings, communal water plans, rainwater harvesting, et cetera, These are the ways we can improve farm SLM practices. We can reduce the amount of pollution. We provide access to water where they are less likely to access polluted water, etc. As you can see, they've made great strides, but the main point of this slide is to understand what our KPIs are and what we look at when we're looking at the success of building a water fund. The second water fund to mention is the Greater Cape Town Water Fund, which may be of interest to you all later. So as I mentioned, each water fund addresses individualized issues or context-specific issues. As we all know, a couple of years ago, Cape Town was reaching day zero, which means that the entire city had no access to water. One of the biggest issues or a critical reason for this water shortage was because of alien invasive species. So our Cape Town team has focused on that. Again, the table at the bottom indicates our KPIs or our metrics of current success, which is very much conservation focused with a little bit of economic activity or economic improvements generated. So for example, hectares cleared, technicalities, kilometers of improved river, etc. The Greater Cape Town is a very unique water fund because of the issues they face. Same in Kenya, where you guys might know in Eldoret, Kapsabet, Iten, we have amazing rainfall and throughout the year. Whereas when you're dealing with farmers in Kwale County, where it's continuously dry, lack of access of water, those are the individualized challenges each water fund faces. So Cape Town was a noteworthy one, and then our final example is the Tanga Watershed Investment Program. For those who don't know, Tanga is on the border of I think it's Mombasa, Diani, and then it goes into Tanga. Tanga is within Tanzania and is a small coastal town. And all water that flows into Tanga comes from the Ziggy catchment. So one river is supplying an entire area or entire small city for all their water supply. And as you can see with our Eldoret, our Nakuru, all our cities are growing into huge urban populations. Again, Tanga is still at the beginning of their water fund development stage, and like the rest, they're facing heavy pressures from urbanization, poor use of farmer practices in the area, and rural to urban migration. When we say nature-based solutions, we believe that they play a critical role in protecting the entire ecosystem. So while we focus on conservation, we're also looking at the human impacts of this. How is reduced polluted river helping the communities? How is access to cleaner water helping the communities, etc.? Yeah, thank you. So those are our case studies. Any questions? Yeah, please. I don't know if you want the mic.
Questions? We were having an interesting discussion on the fires that are happening in the US. So transfer learning, because you guys are conserving the water. Now, in terms of conserving the forest on the other side, what do you think the Trump government should learn from this side
us?
of the world? Yeah.
I don't think as TNC I'm allowed to state political influence. I think one of the success factors is we're not, or the idea is not to come in and bring an idea from elsewhere. The idea is to see what the people are facing in their own context and address it. So a good example is, I'm not sure who knows of the Ogiek community. They live by Eldoret 10. They were displaced from their forests. The government said this is not ecologically safe, move here. But they are apicurists, so they're honey makers, and they live off honey and meat. So the idea is, how can we still utilize the land or the practices that they continuously have known and conjoin them? So whether it's creating beehives to keep 50 meters up in the tree to reduce the impact on the ground, etc. So I can't speak for Trump, but I do believe that we really need to look at context specific, and our resources are available here on the land. How can we better conserve? Yeah.
Thank you so much. Really inspiring talk. I was kind of floored by the situation in Cape Town and the invasive plant that was causing that. I'm familiar with the drought in Cape Town, but I was unaware of the connection to the invasive plant. Can you tell me what is that plant, and what are the types of intervention that are planned there to deal with that?
Yeah, sure. Get you the name of the specific alien invasive plant. It's on a report. For Cape Town, their biggest issue is these plants were sucking out the water and not allowing on the ground surface runoff. So actually the main focus is having people on the ground clearing them. And that was their biggest thing. Exactly. And our success when reporting on Cape Town is X amount of hectares have been cleared. And that has now reduced into X amount of additional water annually being supplied to Cape Town. Yeah, thanks.
Hi, I'm Dennis Fadili. So unrelated, do you guys have water quality analysis on Lake Victoria? Also, have you guys ever, for Lake Victoria, the invasive water species was water hyacinth. So it was really affecting the water quality, but the community figured they could use the water hyacinth for economic purposes, converting it into renewable energy. So have you guys ever tried to use hydroponics to maybe sort of experiment with the invasive water species? Yeah.
That's a great suggestion. I would probably groundwater, as in it's not a catchment area, so we don't actually work there, but I will mention this hydroponics because, we're always looking for new intervention strategies. Thank you. Fine. I'm going to share that with James, or I'll announce it later, the exact plants that are bothering us in Cape Town. Yeah, I'll share the name.
Thank you.
Own design, and looking at the Kenyan system, and mostly in our catchment areas, we have a problem of the land ownership. It's private land ownership, and so we have communities that own land up to close to the riparian areas, and they plant trees like eucalyptus, and they have a say on the kind of trees they plant. Of course, sometimes they've been motivated by other institutions that are promoting ecosystem enrichment who do not prioritize invasion. I don't know how you're handling that conflict, because we have agroforestry promoting trees that are actually affecting the water sources. And so the catchment is draining, especially upstream. Yeah.
Yeah, great question. If we use the example of Kenya specifically, it's very true. And I think one of the, while there's a lot of organizations promoting, diversify your seedlings, X, Y, and Z, I think how we are trying to address this issue is we have carbon guys in the field, and the idea is, okay, we are either providing or distributing at a lower rate these seedlings, But that's not it. We need farmer SLM practices. How are you planting your avocado trees? Are you providing terracing to ensure that the water is being caught at different stages of a steep hill, for example, if your farmland is like that? Which seedlings make the most sense? Most farmers, like in Eldoret, that's a good example, is managu and maize. It's more like, if we are diversifying to passion fruit, I've seen in Tanga cacao seedlings. So it's, as much as it is about, here is an idea, go and do it, this is how you should do it. We actually have diagrams where our carbon guy will showcase to the farmer, you plant them 6 meters apart, you do this. I think it's still a learning process. Each context is very specific, but they are trying to address it water fund by water fund. And how can we scale this and use this information? Thank you.
Great. Thanks, Sachi. So lunch is served by
having learned how to work in that methodology, and also added the final agent, the Python agent for creating plots and some statistics. And the final structure of the graph would basically look like having a primary assistant who deals with basic tuning with the user and identifying user needs, having this part of the graph which is about knowledge bases and retrieval, and basically retrieval augmented generation of themselves in two-dimensional space a bit better. So one part of the process was to convert all the PDFs into enhanced and cropped tables. And then I was able to use the Gemini models to extract data from these PDFs using structured outputs. So that connects the first part of the project, and my goal would be to cases, and then the chatbot would be able to answer questions with current knowledge and current knowledge of Elsevier epidemiology, not just limited to the data which have been manually extracted. Apologies for a very rushed talk, but the result of this hasn't a lot to talk about.
Great, thank you so much, Martha. Yeah. Any questions?
Hugging Face or something like that. The demo that you were showing us, kindly.
Let's use this. To share the link to the live demo.
Sorry, can you repeat? You got a bit cut off.
Yeah, it was whether you're able to share the link to the live demo.
Oh yes, I can share it, but I usually don't have it on for too long because I'll need to be uploading credits all the time. But yeah, with that, feel free to do so. The app I didn't mention that a big part of the process of working with that was figuring out also how to handle multiple users at the same time, and how to separate chat histories across separate users asking questions at the same time, because you end up having the queue form in the app itself.
Great, thanks. If you come up and ask it in. Just
my question goes, in your implementation, have you used RAG to SQL or text to SQL architecture?
I didn't use, so I used more the text to SQL architecture, but to be honest, the SQL part of my workflow is very simple. It just uses, it just makes the LLM transform the user queries into SQL queries, and then it has an associated specific SQL agent, which has its own SQL-specific tools. But I didn't do anything more complex than that. It's one of the basic pre-built functionalities of LangChain and LangGraph.
Hi. So you did
mentioned that you used Gemini 2.0 Flash for your LLM model. So my question is, did you try implementing other different models? If yes, were there any disparities, and what led you to settle on this as the best model? Question 2, is the project open source? If yes, is there a GitHub repo where we can get a glimpse of it?
Yes, so the first question, the Gemini 2.0 Flash, I used it for the extraction of data from PDFs, mainly because I've seen a couple of people talking about them potentially changing. So I've seen some companies talking about switching from using standard OCR techniques for text extraction to rather use Gemini models because of how well they perform with large context windows and the kind of low price of these models. And I also played around with different OpenAI models, but for my use case here, they didn't work as well as Gemini, and I felt that the ratio of price to efficiency for Gemini specifically was very good. For my chatbot work, though, I was working more with OpenAI models, specifically earlier on when I was just experimenting a lot with implementation of the workflow and just testing out different features. I was mainly using Gemini for Mini just because it was very cheap, and I was a bit scared that if I mess up with something, I will have to pay a lot for the models. So I stuck mainly with for Mini, but also switching sometimes to 4.0. And then regarding the open source, so yes, my repository should be available under that link I sent on Zoom. So I hosted the chatbot in Hugging Face, so the whole repository is also there.
Looking at how to handle CSV files and LLMs, so.
Yeah. If I have a chance to give one more comment on this whole topic, I've only started working with these methods, and I only started working with LLMs as APIs like last June maybe, and I found it a very fascinating field, but also it's developing so quickly. It's really nice to have many people who work on similar things and people to talk about that, because it's quite difficult to keep up with the development of the tools on your own. So if any of you are interested in that, it's really nice if you can find other people who work on that and with whom you can discuss the developments, because I haven't seen a field of technology like that develop so quickly in quite a while now. But yeah, very, very curious about how it will transform some science communication and data processing tools in the future. Yeah.
Okay. Wonderful. Thanks so much. And yeah, I'll stay in touch. It would be good to learn more about what you're doing.
Yeah, great. Thanks for having me.
Thanks a lot. I'll put them on maybe WhatsApp to Stan, and then you can share them.
Yeah.
Cool.
Yeah, just plug in. So you can also,
Tim Sarnak. Tim is my colleague, like a new field, and is going to talk about it a little bit, combining some of the techniques that are used to discover drugs with the idea to leverage those techniques in helping to save endangered species. So drug development traditionally targets humans, even though, you know, in many of our drug development programs, we use animals for testing drugs. So Tim will share about this new idea. And I should say it's very exciting. Tim just had a very big feature in New York Times last week, talking about some of his work that he's going to share today. So Tim.
Thank you, Geoffrey, for that kind introduction and for the opportunity to be here. Thank you all for your incredible hospitality. I've been really inspired watching this hackathon over the past couple days. And just inspired in general. As Geoffrey mentioned, we're on a new journey right now, and the big question is, can we make medicine for endangered species? Can we make precision medicine for endangered species? Is our dream. And so I've been traveling through Africa trying to answer this question: what is conservation chemistry? I have so many new ideas for the past couple days I've been here. And so my talk will be broken into two parts, which is kind of follows my life. The beginning was in drug discovery, and I'm very engaged in drug discovery. I work with a lot of pharma companies, consulting now, and I have historically. And then how can we use that to impact environmental health is hopefully where we'll get to. So yeah, for 20 years I've been working towards this dream that you could design, make, test a drug, right? That one day we're going to have a big button that you can push, and you could, say like, my grandma has pancreatic cancer, and I want to treat that cancer, and I need a medicine, and we're going to get better and better at making medicines for these targeted approaches, and events like this are really accelerating this. And so this is a dream. This is not my dream. This is the dream of a multi-trillion-dollar pharmaceutical industry that is pushing towards this accelerated invention of medicine. There's been a lot of data that goes into this, and so systems biology is I'd say an area that is really well established and has lots of data that goes into it. And so you guys are digesting data right now and navigating data, and it's quite tricky, right? But so what we might do is go to our patient, get some tissue, get some cells or some blood, and do a series of analyses on these tissues, looking at genomics, transcriptomics, metabolomics, proteomics, and it's a lot of data that comes out. But hopefully at the end you can digest that data and arrive at a pathway or a protein that is associated with the disease. And then a chemist can come in and say, I'm going to make a molecule that sticks to that protein and treats that disease. When you swallow a pill, it's typically a molecule that sticks to a specific protein associated with the disease, right? And so my career is as a chemist. I like to think about molecules. What are molecules? Where do they come from? And so that's this other side of all of these building blocks and transformations, reaction conditions. And so we've been using AI to accelerate this. The picture kind of looks like this. You have this big blob of the blue thing the light blue thing is a protein. That's what's causing the disease. And we need the yellow thing, the little yellow molecule that sticks inside. It sits in the active site of that protein, and it stops the disease from happening. And then there's other molecules that we could consider, but they don't stick to the protein. They're not good, right? So we want to filter to the good ones, not to the bad ones. The beauty is that we have really nice generative tools for protein structures. Right now we can think about them like movies, and we can generate the impact of this. I don't know how many people here are thinking about molecules in their day-to-day, but so I just want to introduce a few ways to think about molecules that are important for doing this type of research. And so I show you 3 different representations of the drug Tamiflu. We're very worried about avian flu in North America right now, and so I talk a lot about this molecule right now. And so you can see that there's a line and stick drawing up at the top. If you've ever taken an organic chemistry class, maybe you've seen that. I love drawing hexagons like this all day. I can just sit at the chalkboard and draw such things. It's got a name, oseltamivir, or it's got a brand name as Tamiflu. And then the bottom one there is what's called a smile string. And so if you've seen this, great. If you haven't seen it, then it's a way to communicate that chemical structure. If I take that string of text, it describes the exact same molecule up top. There's another way to think of these molecules that's really relevant to me. One, there's 2 definitions here. One is that it's as a graph. Okay, so hopefully you can see that the bottom structure there is the same one as the top. It's got, but rather than the carbon and nitrogen, there is nodes and edges. And another important component to this is that it's being built from smaller pieces. this is where medicine comes from, right? Or synthetic medicine anyways, that you have pieces and Lego blocks and you like click them together to get the structure that you want. Often I would talk a lot about our work in digesting graphs to optimize synthesis. I'll just quickly show you that this is a very short synthesis of a natural product we were after, and we used graphs to get there. And I want to highlight here these reaction conditions. These are kind of a difficult part of the recipe that we need to get to. I'm bringing this up just because I wanted to talk about some of our work with LLMs. And so to identify these reaction conditions, we have to look through a lot of possibilities. There's like 10 to the 70 possibilities that I could go into my lab and make a mixture of different reaction conditions any day. So this is pretty antiquated. This is from February of 2023. So this is like kind of one of our first prompts in ChatGPT. It's become a lot more sophisticated. But so we're just telling ChatGPT, generate a 3 ligand by 4 catalyst by 2 reaction array to run this type of reaction. And this is the output. And so now what you see is that I have a series of reagents that have different reagent classes. And I can go into my lab and I can mix them. And we do that. And I think one of the reasons that I like to show this to this audience is that I find that LLMs are really good at giving an approximation, right? But they're not good at giving the exact answer. And so we have a tool that builds these arrays. What you're looking at, all the pink and purple dots, each square is a different chemical reaction that we ran. And there's one of them that's really good. And so it's like ChatGPT, when we asked her to give us this recipe, she gave like a good approximation, but not a good exact answer. And so there were, by building this array around that, we get a kind of a sampling of the space around where we were asked to look. And there's only one really good answer within there. But okay, so we're good at making molecules. We're good at designing molecules. We design, make, test, and we can make molecules really quickly. Here's a particular selective cancer molecule that we've made for human patients. These are human cancer cell lines, and we used all of our AI tools to generate this particular molecule, and it's very exquisitely shutting down cell cycle arrest in these cells, which is what's shown here. There's a lot of exciting ways to leverage such information for medicine. And again, the pharmaceutical industry, I think, is really pushing towards this, button that you could get a drug for any disease. And so the question we asked is, what if our patient wasn't a human? So what if we then approached the situation and said, what if we encountered a health situation that was, not a human? So these are some of the patients that we're currently working with in my lab. They do not have good health care. They don't obey all of the biological rules of what we know about human medicine, but there's a lot of things that do overlap. And I guess I spent a lot of time, I did this out of a passion for conservation, it's like, should we really invest resources in saving a penguin? I don't know, but this notion of One Health, I think, is one that hopefully will resonate around this room. And so this is a really fascinating paper that came out late last year from Eyal Frank in Chicago. And so one of the diseases that we work on is called white nose fungus, or white nose syndrome in bats. Bats in North America contract this fungus and they die very rapidly. So it's a really big problem for us. We're losing our bats. And what Professor Frank has done is looked in the hospital records where this disease was reported. And what he noticed is that there was an 8% increase in human infant mortality. Okay, so we were gung-ho on making drugs for bats because we thought bats were cool. We wanted to save them. And then this paper came out. It's like this is like an 8% increase in infant mortality when bats contract this disease. You start to unpack it, and what is the ecosystem of a bat? Ecosystem service of a bat, right? Is to remove insects. And so when they disappear, there's more insects, right? The farmers spray more pesticides on their crops to deal with those insects, and it's well known that pesticides correlate with infant mortality. And so it's kind of this direct, connection of human health to ecosystem health. All right, so let's go to Florida and take a look at some of the work that we're doing with the Loggerhead Marine Life Center there. They unfortunately pull about 5 sea turtles a week out of the ocean in this condition. They are battling a infectious cancer, and this is now the major stranding event for these sea turtles in Florida. Here's Bellatrix is a sea turtle who's about to undergo a procedure to have these tumors removed. But what you can see is that she's just covered in cancerous lesions, right? It's gross, I'm sorry, but it's, and so what you see on the right is a drug target that we have pulled out from sea turtle cancers. And now using AlphaFold, which is a new tool that you can generate a protein structure, gives us this 3-dimensional picture that we can actually start to look and get in and start doing drug discovery. And so we have an incredible arsenal of cancer drugs available to us today. And so we find it fascinating that, that these sea turtles are battling cancer at a time when we have access to a lot of new wisdom around cancer medication. I'm going to take you now to the northeastern forests up around where I live, and this was actually our first patient was a tree. We started working in trees, and it was an interesting decision to start in trees. But this one in particular is really important to our ecosystem, and I want to share why. So it's called the hemlock tree. It's the state tree of Pennsylvania, as one of our states. And it carries this really important ecosystem service. So this is a photo from the same place in Michigan in the summer and the winter. And our forests are, they have a dense canopy of leaves like you see here. But when the winter comes, all the leaves fall down, you see, and it kind of gets covered in snow. It's lovely. But this tree is a conifer that can live in the shade. It's the only conifer that we have in North America that lives in a shaded environment. Normally we need bright sun for our conifers, like your pine trees or a spruce or a cedar tree. This one particular tree can grow in the shade, so it can grow under the canopy of the forest. And you can see why that's important in the winter, because the trees drop all their leaves. And so now we have some cover for our animals throughout the winter. These are really, really critical trees to our ecosystem. Unfortunately, we have lost a very large number of these trees to an invasive insect. So there's an insect called the hemlock woolly adelgid that came in from Asia, and it has wiped out this tree in most areas where it is. It's only just recently reached us in Michigan. And so this is one of our important national parks. This is the Great Smoky Mountains, and every tree that you see that is living is not a hemlock tree, and every tree that is a hemlock tree is dead. And so this is a big problem. Here's the insect, and it creates this kind of white waxy coating around itself. It like sucks the blood out of the tree and turns it into this white wax. And so we thought that might be important. You can see the spread of the insect. It was introduced to North Carolina on someone's bonsai tree in 1951, and you can see it's just spreading across the country. So we're looking at this through the lens of tackling it through its white wax producing mechanism. But I want to introduce you to another insect of our forest. This is the boogie-woogie aphid that is also a white wax-producing insect that's kind of wiggling around. My daughter hates them. I'm always like gathering them from the woods, but my 8-year-old daughter is very angry whenever I'm like, oh, come look, there's boogie-woogie aphids over here. But what we would like to do is selectively target this hemlock woolly adelgid while not impacting this boogie-woogie aphid that has an ecosystem service that it plays. And so we've recently sequenced the genome of the invasive insect, and one of the proteins that we intend to go after is shown wiggling here, which we can generate these structures using new generative AI techniques like AlphaFold. So we'll go now to Panama and all through Central America. The frogs of Central America are in a really bad way. I went up to the Aberdares, or the Aberdare Park. It's the most beautiful place. It's incredible up there what you guys have. And I told the game warden I want to see frogs, and he laughed at me. Apparently you don't go to the Aberdare to look at frogs, but I'm very interested in frogs. We are unfortunately living through a mass extinction event for all amphibians on this planet, and so we've lost about 400 species of frogs to an invasive fungus called chytrid, and so these are some frogs in California. I had some fun looking around at some of your native frogs. So these are all frogs from Kenya, and that are, it's kind of this really beautiful diversity. Maybe the colors don't show up so great, but there were hundreds of Kenyan frogs that were just like beautiful to look at. Except the yellow one here is actually not from Kenya. This is the Kahansi spray toad, which is from Tanzania, and it is extinct in the wild. And so it is being preserved within zoos, but through this fungus, and through habitat loss, this poor little frog is on its way out. And if you think about what I said earlier about the bats, right, that when the bats get a disease, infant mortality goes up. What is the ecosystem service of a frog, right? They remove insects from the ecosystem, and so, it's maybe hard to think of a frog as an important patient, but they really are a critical part of our ecosystems that we need to respect. Now, luckily, one of my dear friends and partners on this mission is Tim James, and he had developed a really nice model system using these African dwarf frogs. Does this frog look familiar? It's an African dwarf frog, so I don't know if I'm in Africa, so it's just always been this interesting. But anyways, they're widely available in the pet trade, and the interesting thing is that they're easy to infect with chytrid fungus, and so we have this system here where this is loaded up with the 400 frogs, and we can do all types of experiments to look at them. Here's some of them swimming around. I guess it's not really showing up great, but they're tiny little frogs, and they're easy to breed in an aquarium setting, and so it allows us to very quickly take our findings from the lab and do clinical trials in this model system. What that looks like is using some of the drug discovery tools that I mentioned earlier to find antifungals. And what you're looking at here are dose response curves. And there's two drugs, or actually three drugs, that are like right at the bottom. Those are incredibly potent antifungals for killing this chytrid fungus, like incredibly potent. And so we're hopeful that we can use that as a tool to mitigate this situation. And working in African dwarf frogs, as a model to these two frogs from Panama, one is the Panamanian golden frog, the other is the lemur leaf frog. This is work that we do in partnership with the Smithsonian. Brian Gratwick is a leader of Panamanian golden frog rewilding. But the problem is that the frogs just get out there and then they rapidly die from the fungus. And so we're trying to work with them and understand how we can bolster their immunity and provide treatment options. All right, and I want to end with a story that takes us, it's actually happening all in Ann Arbor, Michigan, where I come from, but the animal is a Gila monster, which is from the deserts of Arizona and northern Mexico. And so this is a really fascinating story. We were at a zoo doing our holiday party and talking about frogs and turtles and some of this work that we were very interested in. And the zookeeper said, you're talking about this wildlife disease. We have a Gila monster that we are about to euthanize because he's got cryptosporidium. It's a parasite that there's nothing that we can treat this animal for. Now, as a pharmacist, this really resonated with me because the Gila monster is where we got the drug Ozempic from, or at least the saliva. It was the first generation of this weight loss and anti-diabetes drug Ozempic. And I don't know if you guys are familiar with this drug, but it's completely changing the game of diabetes treatment around the globe, and is raising billions of dollars. And so they're selling like $4 billion of Ozempic a quarter. And yet the animal to which we owe some debt of gratitude for this drug is about to be euthanized because it's got a disease that there's no, no treatment for. So we got interested in working with Pebbles, the Gila monster. Here's Pebbles, and she was battling Cryptosporidium. She needed to be kept separate from all the other reptiles in the collection. And it's really quite challenging when you bring in a reptile that's got Cryptosporidium because it could infect a whole collection if you have that. So here's Dr. Muhammad Ishfaq working with the team at Creature Conservancy, extracting some of the stomach contents of Pebbles, and we put those under the microscope. And it's just bizarre. It kind of becomes apparent why it's so darn hard to kill this thing, because it's got this really protective shell around it in panel A. In panel B, this is a different life cycle of the parasite, and you see it's got this kind of egg-like coating around it. And so this is just very, very well protected. It's very difficult to work with this. But we did use LLMs to solve this problem, and I wanted to show this tool that we're building. It's quite early in its development, but it plugs into a different component called Semantic Scholar. I don't know if that is familiar to anyone here, but Semantic Scholar is like a library networking tool, and so it will tell you what papers cite other papers. And so this has been really beneficial to us because what we can do is take 5 papers that we find on Google, just do a Google search for 5 papers, drop them into Semantic Scholar, and then it will build the whole landscape of this paper cites these papers cite these papers, and then you get 100 papers or 300 papers and kind of get all the information about a field of research, right? So now we've got hundreds of papers related to Cryptosporidium, and then we use ChatGPT to read them and identify drug names. And so from those drug names, we built a simple histogram like this. We've been doing more to inject context into this. These are context independent, just is the drug described in the paper, yes or no? But what you can see is there's 2 drugs that are really the outliers. One is paromomycin and one is nitazoxanide. And we went with paromomycin for reasons I can explain if you're interested. And we were happy that we did. And so here is Cryptosporidium from Pebbles that has been treated with paromomycin. And what you see is these big white kind of crystalline occlusions. We never saw that without treating. So this drug is harming this parasite in some way. As well, you can, I don't know how easy it is to see on the slide, but that kind of really thick, non-penetrable layer is getting a little bit busted up around the edges, and so we feel good that this drug is doing something. So then with our veterinary team, the drug was formulated into quail and fed to Pebbles, and she got 8 grams of this drug over the course of 2 weeks. And I'm excited to report that our first test on her was last week after treatment, and she's negative for Cryptosporidium for right now. We need to continue testing and hope that we are there. But as well, the zookeeper says that her appetite has come back, and so hopefully LLMs were helpful in making this intervention. In trying to work with an endangered species that was slated for death, right? I mean, when they realized the animal was sick, the plan was to euthanize, to get rid of it. And yet, we owe a multi-billion-dollar pharmaceutical market to this creature. And so I think it was a really fun way to use LLMs to pull in a lot of information. And so as Jeffrey described, we're very excited about this new direction of taking all of the things that have been developing for human medicine, which have come a long way, right? In the same way you guys are witnessing LLMs advance, you can imagine that drug discovery is accelerating at a rapid pace. And so we imagine that one day it will be accelerated so fast that we could go beyond humans and imagine patients, regardless of how much healthcare they have, but really based on the ecosystem services that they provide. And so with that, I just want to thank these sponsors and this incredible team of researchers I get to work with. Thank you again for this opportunity, and I'd be very happy to take any questions.
That you have mentioned about citation mapping and what it can be integrated with cancer. Yeah.
Sorry, on this stuff.
Yeah. So the conventional thinking around cancer is that it cannot be cured. And so as you are building on these LLMs, which credible resources can you suggest that can actually challenge the status quo regarding cancer treatment? So that as you're building on these LLMs, we are having data that is accredited and credible.
So I understand the question was about cancer specifically. Yeah. So and then how do you know that the data is credible that's coming out? So, I mean, I think that if we think about populations, right? That you know, the more data you get that's reinforcing a hypothesis, I think the better it is. So that's why we like kind of this notion that there's more papers saying the same thing, right? That everything is really noisy, right? And people are motivated to publish papers because you have to publish a paper, right? If you're academic, that's like your currency. So you kind of have to publish the paper. And so what that means is that people might have maybe not so robust results, which I think is what you're getting at. So hopefully, if you have, you know, an ensemble of papers that are saying the same thing, that gives you a bit more confidence. I would say that, you know, I would push back on the notion that cancer can't be treated. In the past 10 years, I think there's been a lot of headway, particularly when we look at ways to teach the body, teach the immune system how to fight the cancer. I think that has been really one of the keys, that there have been a lot of anti-cancer drugs that the first generation were just very, very poisonous, right? So they just kind of poison all cells, including yours. And so the cancer cells are growing faster. And so hopefully you can kind of get ahead of it. But, you know, then it's very, very taxing on the patient. They don't like it. In the past 10, 15 years, there's been a wave of drugs that partner with those types of drugs that are more targeted. And so as long as the tumor hasn't spread all throughout the body, there are some options for some types of cancers that I would say are getting increasingly better. Unfortunately, they're very, very, very expensive, right? And so this is the problem that we're up against right now. But my hope is that LLMs will in part, you know, just make it so much easier to invent new ones, and the cost will just keep coming down.
Thank you
So much, team. Yeah, it's a real pleasure. I think one of the reasons also we are having, like, you know, very different topics in very different domains is that the greatest discoveries come at the convergence, right? And I think that perhaps the greatest lesson that we can have is that many of the technologies that we are building today eventually are going to enable us to integrate knowledge from very diverse domains. So like the LLM that, you know, you're trying to build an LLM that can extract contextualized information. Once you do that, you can contextualize information in chemistry, you can contextualize information in agriculture, and you can link those two areas. So Tim showed, like, you know, the structures of chemical drugs. You can imagine the same LLM will be extracting chemical structures from those same papers, because some of the scientific papers that talk about ecosystems, they mention trees. These trees have natural products in them. And so you can imagine how all of this can intersect together to accelerate the way we develop solutions across domains. So what you're doing basically with LLMs enables you to enter in future into any of these industries, no matter what your background is. And what we need to learn, or the greatest skill you need to acquire, is this ability to be able to work across those diverse fields. So you don't need to be an expert in everything, but you can listen to the most important parts that allow you to integrate the knowledge. So thank you again, team. And yeah, I think maybe we should continue to work on our projects. And if there's any questions, just let us know, and yeah, we'll come and support you.
I'm enumerating over my text chunks here, and I think there's like 40 in this article or something like that. And I'm just saying, hey, ChatGPT, you're an expert at chunking this data into facts that will be used by a RAG model. Turn the provided text into a series of questions and answers that can be answered by the text. Make sure you include specific quantifiable metrics where they are given. So, and then I tell it the format I want. I want a question and an answer. And I tell it, don't return any extra text, only valid JSON. Does anyone have any ideas why I ask it for this format, where instead of just pulling out, breaking up the chunks into facts, I tell it to break it up into questions and answers? Anyone have any ideas? Yes? Say again? Questions and answers instead of just breaking it up into facts. Familiar with text embeddings? Have you used them already for your RAG models so you could fetch relevant data? Well, typically when you run these embeddings, you're passing in a question, like the questions you may already have. And the first step you do is you embed your question, and then you're going to find similar things related to your question. But you're going to find much better similar things if you're trying to match to other questions. So what I end up doing is I don't embed the answers at all. The answers are kind of just extra. I embed all of the questions, though. So once we go through, at some points, so this is me just getting all the data, and then I embed all of the questions so that when I use my RAG model to fetch information related to my question, it grabs the questions and answers related to that. So yeah, that's my chunking method. Any questions on that? Yes? Can I what? Repeat it? Okay. The main magic to the whole thing is I am breaking it up into groups of 250 words. You guys are probably all doing something similar. 250 is arbitrary. You could play with that. But then the spin I'm putting on it is I'm not embedding those chunks at all. I'm kind of I don't get rid of them, but what I'm doing with those chunks is I'm passing them to ChatGPT one at a time. And I'm saying, hey, ChatGPT, turn this chunk of 250 words into a series of questions and answers that are related to this chunk. So it's turning that chunk of random 250 words into meaningful questions and answers that are really easy to do a embedding search against. That make sense? Yes? Yes. 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 That's a great question. That was going to be the next thing I brought up. He asked, is this scalable? So that is the only problem with this method, is it is slower and not as cost efficient as if you just embedded the 250 words directly. But what sort of costs are we talking about? I could tell you, I do a couple million of these every single day doing this exact method using ChatGPT 4.0 mini as my model, and it costs me around $5 to $10 a day for millions of these. So it's relatively affordable, and there's even cheaper models out there, of course, than the OpenAI models. But for millions, you could get away with only a couple of $, and you're fine. Yes? Any other questions? Yes? In terms of speed, it takes about, so in this case, It takes about 2 seconds, 3 seconds per chunk, and this article had 40, so it took about 2 to 3 minutes to do this whole article. But then once you have it done for one article, you just save that data. You never have to do that article again. You're done with it forever. Oh, yes. Question? It's totally up to the AI model. So it could be 1, it could be 0, it could be 10. It's whatever it can decide to do. No, I could if I wanted to. So if I wanted to, I could tell it instructions like always do at least 5, and it would kind of do a bad job if it needed to make up some. But because the key thing I did here is I told its format is this dictionary format, which implies it could create an entire list of objects. So from this, it was able to kind of know that it could do as many as it wanted. Does that make sense? You seem... You could, I mean, yeah, in theory, you could build another model of some sort to kind of verify and go through. I didn't here. For the most part, you're giving it a very specific piece of information and telling it to do a very specific thing. It should be fine. I could tell you, I do this, it should be fine. I do this for work, and people, my clients for work are like traders, professional, institutional people trading on this information, and this is exactly how we do it. So I hope it's fine, and it hasn't run into any problems yet. So your question is, if I run this process on multiple articles, will the same question kind of pop up throughout the different articles? I think it just totally depends on the use case. And you definitely would expect it to happen, especially if you're doing lots of articles from as you were kind of showing, lots of papers that are talking about a very similar topic. You would kind of expect the similar or the exact same question to kind of pop up, and maybe they'd have a totally different answer because they're doing it different ways. So the short answer is yes, I would kind of expect that. And then you could, if you did this exact method, you could kind of do a really cool analysis to figure out what are the most conflicting topics. Yeah, that would be really cool. Anything else? All right, the figures. So, let's see. Technical difficulties. Give me a couple of minutes here. Yeah, I've never seen this. I could restart it. I'd like to avoid doing that though. That was a hard one. Yes. Okay. Okay. Well, hopefully you find this helpful. So it was definitely a tricky one, and it was more of a data cleaning problem than an AI problem, but the two go hand in hand. Like when you're working in data science and stuff, like half the battle, annoyingly, is always cleaning the data somehow. So the first thing I noticed when I got into this is this actually, even though it's a figure, it's not an image. It's a table. You could highlight individual things. It's just a formatted table. So when you extract it, you can't like copy and paste, extract the image out of it. But what you can do is you could extract the table out of it. So I opened up a ChatGPT, and I just went to regular ChatGPT, and I said, hey, can you write a script for me that can extract table formatted data out of a PDF? And it said, sure, no problem, I got you. And it introduced me to this, a package I've never used called Camelot. And I don't really know, I never heard of it, but it worked great. Camelot has a built-in thing called camelot.readPDF, and it extracts the tables right away. So that pulled out all the tabular data from each figure. And let's see, I go to tables in here, table 2, for example. But it came out in a really ugly format. So this is what Camelot was able to pull. It was at least able to identify the chunks that were tables, which was really helpful, but it was this really, really ugly, just like passing in that really ugly CSV. And I said, hey, ChatGPT, you are a CSV data organizer. Your task is to clean and organize CSV data. Ensure the headers are clearly defined and columns are correctly aligned and extraneous data is removed. Please respond with the organized CSV data. And then it did okay the first time. Then I realized I had to add this last line to its information to get it right, because it was actually getting it slightly wrong. It was giving wrong numbers to wrong rows, but I figured out why. What it was doing, it was getting really confused by these x-axis numbers that were popping up randomly in that ugly CSV. So I had to tell it, there may be some random numbers, for example, page numbers, embedded in the CSV. Ignore those. Use your best judgment based on consistent formatting to identify which values should actually be in the CSV. So I gave it a heads up that not every value needs to be in the CSV, which was important because it made everything align better. This is a relatively complicated task for ChatGPT. I actually used their O3 mini model, which is a reasoning model. So this was relatively slow, but it was a small amount of data, so good way to clean up the data. And lo and behold, bada bing, bada boom, it worked great. So extracted data, organized, figure 3. I don't have Microsoft Excel, so this is how I look at CSVs. But here it is, all organized, nice and clean data for all of our figures. So now that we have our CSVs nicely, any questions before I kind of move on on organizing the data, cleaning the CSVs? Okay, that was the hard part. The rest of it's totally chill. The rest of it's super easy. So figure. So when you're dealing with tabulated data, you don't want to use the embeddings that we were doing before. That's only really for text data, and this isn't text data. Even though it has like words and text in it, these are not sentences. You only want to use like the text embeddings when you're dealing with things that have commas and periods and grammar and full sentences. Never use text embeddings on stuff that looks like this. It won't work. So for stuff like this, you just want to treat it like a CSV, treat it like data, and write code to access it. And that's exactly what we do. So for building a model to access data from these CSVs, I have a ChatGPT function that I give it a tool. And you've heard a couple talks today where they talked about using tools in their LLMs. But basically, I gave it a tool that has an ability to run a script. And I gave it a description. It compiles a Python script and returns the output. Only what is printed is returned. So I'm giving ChatGPT the superpower to write its own code and compile it. And I had to write this run script function that basically runs the script. So what ends up happening is ChatGPT decides to use this tool. It'll write a script, and it says, hey, Eric, I need you to run this script for me. And then I run this run script function for it and return its output to ChatGPT. I don't literally do that. The code kind of does that in a loop. So it says, hey, run this function for me. Here's what I want you to plug in. Here's the output. And it keeps doing that as many times as it needs to until it's satisfied. So here is the context I give for this figure rag. I say, you are an expert at answering questions based on information in a research article. Figure data is provided as CSVs. Use the run script tool to read in these CSV files and write Python code to find relevant information. Anything you print will be returned by the run script tool call. This is an important line right here. Feel free to use the run script tool multiple times if needed. For example, you may first need to print column values to know the structure of the data, then write a separate script based on that information. So I'm telling it that it can write multiple scripts because that's kind of what it'll need to do, because first time it might need to write a script just to print the column names of the CSV. And then it'll say, okay, now I see what the CSVs look like. Now let me write a new script that pulls the exact information I need. And then it can iterate on itself a couple of times. So let's run it. So this is the main question we were doing. What is the difference between the impact of trees on croplands and PES on food security? Hopefully, it'll be embarrassing if this doesn't work this time. So here it goes. This is kind of small font to read down here, but right now it just wrote, I'll kind of walk through it. So here it's asking the question. It started running the run script. The script it ran is just to read figure 3 CSV. Oh, important detail. I gave it the figure legends for each of these figures too. I have a script that automatically extracts those, so we could automate this whole process. But so it knows it wants to access figure 3 based on the figure caption. And it says, okay, just read the columns. Give me the columns of figure 3. And there they are. Outcomes, subgroup, study, effect. And then it writes another script. So now it's running another script, and it's saying, print the unique outcomes and print the unique subgroups. And then it's doing a couple of things. I'm not going to read all the script here. But here's the data it's pulling out, data it's pulling out. It's running another script, so it's iterating on itself, getting all the information it needs. And then eventually, it says the average effect for PES is 0.15. The average effect for trees is 0.25. Now, if you remember, this is kind of funny. Sometimes it gets a different answer each time you run it. The correct answer was 0.07 because it was subtracting this 0.16 and 0.23 to get 0.07, right? If you guys saw that. This answer is saying the answer is 0.1 because it's doing 0.15 and 0.25. Sometimes it gets 0.07, sometimes it gets 0.1. I've run it a few times, and here's why. It's kind of silly. Even though it says here that the average is 0.23, if you actually average all those numbers, they average to 0.25. And even though it says the average here is 0.16, if you average all these together, they average to 0.15. So if you read the text or something, these might be actually like a weighted average. I'm not really sure. But sometimes the LLM is deciding to calculate the average itself, and sometimes it's deciding to just use this value. So depending on what it decides to do, it's going to get a slightly different answer. But I think both answers are kind of correct. It's pretty good. So yeah, that's that on how that's working. Any questions or anything? There's one last step I'm going to show at still. I'm not done yet, but yes. Sorry, say again? Yes. So the run script function basically allowed the ChatGPT to write code that is actually compiled. So if you just handed ChatGPT the CSV itself, it's going to have a really hard time pulling information from hundreds of rows, trying to find the right answer. And then it also, in this case, it needed to average certain values together. It didn't need to technically, but it chose to. It can't really do that in its head. LLMs aren't great at math, but what they're great at is writing code that's good at math. So instead of telling the LLM to specifically just handing it the CSV and say, hey, get me the data I want, I'm telling it, hey, write code to get the data you want. And it's writing the code to get the exact data it wants. Does that make sense? Yes? Sorry, say again?
Does the script run after for every prompt?
For every prompt. What do you mean by every prompt? No, so it decides if it wants to use the function. So if we go to the code, actually I'll show this in a little more detail in the next thing I'm going to show, but basically anytime you give your LLM access to tools, it decides which tools to use and how many times to use them. It's totally up to the LLM. And then the script actually runs, yeah. So the way the code kind of works, it kind of feels like magic, but the engineering of it all is in this ChatGPT function, I have this while true loop. And basically, it's if the message that it returns from the LLM has a tool call in it, I say, we run that tool call. So in this case, we only have one tool call. So I say, if there's tool calls in the message, we loop over those tool calls. If the tool call is run script, we run our run script function where we plug in the script that the ChatGPT gave us. I said the word script like 30 times there. But basically, ChatGPT is writing a script for me, and I'm plugging it in here into the Python run script function, and that gives me a result. And then I pass that result back into my chats with ChatGPT. And then we could iterate this process all day where it could keep writing scripts for me and I could keep giving it the answer. But eventually, it'll give me a response that doesn't have a tool call. And at that point, it just gives me the final answer. And then that's when the while loop breaks and it returns the final answer. Yes? Sorry, one more time.
So the question is actually about the approach.
Okay.
I kind of got stuck about how did you identify that was a table and not an image?
How that was, when I opened the PDF, I just kind of like highlighted it and played with it. I kind of just tell. I'm assuming you're asking about automating this process if we want to scale this up. Camelot, or yeah, I never heard of it.
Because the library I used did not identify it as a tool. I extracted it as an image.
Oh, interesting.
So that means, depending on the library you use,
Could give you different answers. Totally. Yeah, well, so I think with this, the way I think of it with this pipeline I have set up here is you could pass any PDF into what we've just gone over, and obviously it'll have no problem pulling in the chunks and embedding those chunks of the questions and answers. And then you could also pass into this next script I wrote, and it will pull any table information. So there could be other papers, tons of papers have tons of tables in them. So this generally solves the issue of extracting information from tables. So now the two problems we kind of solved are the texts and tables. The problem we haven't solved yet is image figures. Like for example, figure 2 in that paper is a map. We have no information about that map here. And to be honest, I don't know how to solve that problem. That's way too complicated. Parsing information, turning image data into like quantitative data is a really big problem. It's a really hard thing to do. Any other questions? Okay, so last step that's kind of fun, I guess, is combining these two things. So they don't have to live as separate things. We don't have to run our text model and our figure model. We can combine them. And that's what this looks like. So now I give my ChatGPT 2 tool calls. We're getting fancy. We have 2 tools now. Tool number 1, we have run script, same thing, haven't changed anything. And then tool number 2, I called it get information. And what get information allows it to do is this whole thing we talked about in the first section with RAG, where it says, given a certain query, find me the related questions and answers in the text related to that query. So let's run it. So the question I have plugged in here is, what are the most important impacts of tree-based interventions on health and well-being? This one usually turns out pretty cool. Okay, so here's the question. It's thinking about it. What are the most important impacts of tree-based information? And now it's running the get information. So it's fetching information related to this query, and here's the first question it pulled. What can we enhance the nutrition benefits of forest interventions? The answer is pairing forest interventions with measures that increase communities. Next question is, how does the impact of forest exposures on dietary diversity compare to other interventions? Answer, the impact is comparable to some multi-nutritional blah, blah, blah. So these are the questions. It's pulling the top 5 most related questions and answers related to this, and those all seem like questions and answers related to this question. Then it's running get information again, so it's passing in another query, which is kind of cool. So it didn't just run the query we handed it, it's deciding to run multiple queries to get a wide array of data. So it's getting different questions, and then it finished all of its fetching text data, but it didn't give me the answer yet. Then it decided to run a script. So now it's looking at figure 5. Figure 5, what is figure 5? Blah, 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 blah. Yeah, it's about well-being, child growth, and access to education. Positive effects indicate good outcomes. So yeah, this is the exact figure related to this question. So it's reading in the figure 5 data, and then it's running another script to get some more quantitative information about figure 5, and then it's finally done. So then we could say, let's just print the response. It gave me this really nice response with a lot of text evidence, and it also has some quantitative information embedded in the response. So I'm just going to read a little chunk in here that has some quantitative information. 2 studies of trees and croplands, for example, reported effect estimates of about 0.78 and 0.25, suggesting that people feel better about their lives when trees are part of the farming landscape. And then it cited those 2 papers, 2002 Chi. So it's able to construct this answer based on both the text data and the figure data, combining it to make a really, really cohesive answer. So yeah, that's pretty much it. Any questions on putting it all together? Cool. Well, the last step, I mean, this is basically the last step, but whenever I present something like this, if I have to like present to a professor or something like that, here's just a little life hack if you guys ever want. I never like to present like this. I present it like this to you guys because you guys actually write code and appreciate looking at the code. But a lot of people don't understand what a Jupyter Notebook is. So you could just ask ChatGPT to take whatever you did and turn it into like a Python Dash app. Have you ever worked with Dash apps before? Oh, cool. Well, you should look up Dash apps. They're great. But in like about 30 seconds, you could turn all of that code into, one sec, Control C, up, run, copy the URL, should have had this open already. Now we have ChatGPT, and it works perfectly. So you could just paste in this question. And it has just a perfect ChatGPT experience so that anyone could play with this, and you could sell it as a product if you want, I guess. But yeah, that's everything I got to tell you guys. Dash apps are awesome. That's how I chunk data, and that's how I turned the figure into CSVs and taught ChatGPT how to write code against it. That's everything. Yes? Yeah. So that was part of the final. So you're asking, how does the whole question and answer thing plug into this final model? So when I combined, here's the answer finally. So basically the same answer printed out, nice ChatGPT format. But so I combined all the context from the first version with the text rag and the second version with the figure rag. I turned all that into one big piece of context, where if you see up on the TV right there, this is my context for the final one, where this is basically everything about the figures. Feel free to run the script. We read this out loud before. That's all the figure stuff, figure. And then I pasted this from the text stuff. I said, you're also able to fetch contextual information from the article using RAG, using the get information tool. This works by giving an input query and returns the 5 most relevant pieces of information. So throughout this entire context, I'm telling about 2 tools it has access to. The run script tool, which is for reading in the CSVs and accessing data. And it also has access to the get information tool, which uses the question and answers to, and the text embeddings to find the most similar stuff. And if we scroll up, we could actually go to that, here's the get information tool that it's actually running. So when get information takes an input of a query, it embeds that query, and then it gets the top matches. So I find the most similar questions and answers, comparing my chunks to the embedding. So the chunks are here, the embedding's here, and I take the top 5. And then I get the questions and answers, and I return the question. This is technically questions and answers, but I call the variable answers. And I return the answers. So that's what's going on there. So I'm basically giving all that information to the LLM, along with whatever code it ran, and then it makes its answer based on all of that information. That make sense? Mm-hmm.
So in that case, we have to kind of look for a question answer here that's similar to the query.
Right, yeah, so, well, okay, very good question. So let me actually keep reading the context. So if you remember in that example we just did, and I showed you the output, it actually did the get information thing 2 times. And you might be wondering, like, why would it run it 2 times if there's only one question? Well, I'm telling it that it doesn't, I actually kind of tell it right here, that it doesn't need to pass the exact query that we handed it. Actually, let me just read what I wrote. I said, you are also able to fetch contextual information, blah, blah, blah. Feel free to use this tool multiple times with different queries to get a broad range of information to make your response well-informed. Your query does not need to be exactly the same as the question provided by the user. You can be creative to get a wide scope of information. So I'm telling it, even though I'm asking one specific question, it could then take that and then ask 5 different questions to get, relevant pieces of information, and then each question returns 5 question answers, and then it has all that information to create a well-informed answer. Does that make sense? Okay, cool. Anyone else? Last chance. All right.
Please tell us, how far are you with the 2 questions shared for task 1, the one which was shared today? And also any challenges so far?
So our model was running fine. The scores were relatively good. So we were testing specifically with DeepSeek, and we got...
Add some more sound to it so that they can hear.
Oh, so I'm saying,
yeah.
Our model worked fine. We got relatively good responses. The scores were updated.
Yeah.
So currently with the 2 questions, we were testing specifically with DeepSeek model,
yeah,
so as to gauge from the target to the predicted.
So how are you evaluating the generated responses? How are you evaluating versus the ground truth response? How are you evaluating that?
So we were implementing similarity searches for this model was lemma index,
yeah,
but then we did try as well cosine similarity. So still a bit of fine tuning, but yes, we are on the right track.
All right, thank you so much. Any challenges from team 1? No challenges.
Yeah, but we've mitigated some. So we've encountered some, but we've found workaround solutions around them. So.
All right, and as regards to the second task, how far are you with that?
So we were, as we were finalizing on the task 1, we had some members of the team starting on task 2, so that we worked concurrently on the sort of divide and conquer. So for the members who started on task 2, they've leveraged Gemini, and it's providing responses and basic analysis on the CSV data, but still we are yet to explore other models. So we have like a prototype that's working, but then still building on top of it.
All right, thank you. Team.
Task is a bit challenging when it comes to the embeddings, but we are equally up to the challenge. I'm sure by tomorrow it will be working.
So what specific challenges are you having with the embeddings?
For now, I can say that they are all over the place. Nothing is quite correctly working. Okay, it's working, but it's only working to a certain level. But I'm sure by tomorrow morning.
Based on the embedding, we were trying to check which embeddings are, like which embedding models, are they the OpenAIs or which ones. So we were trying them to find which one will return the best results. Yeah, so that's what he was basically saying.
And is the challenge regarding to similarity or?
Yeah, actually, it's regarding to similarity. Yeah. So we decided to move forward with the OpenAI embeddings. Yeah.
All right. And what about task 2?
I'll hand over to my friend. He was trying to hack my code. but we've been able to load the CSV file and even query. In the morning, he was able to break the query, but I've patched it up. He can explain some more.
So based on that again, we've been able to, so far we can work with one CSV at a time, but now again we are looking at which LLM will perform best. So far we were using one from Google, but it was breakable, as you said. Yeah, so we are trying to check again which one will perform best. Yeah, as we are adding other tools.
We are done with task 1, as you can see.
Task 1 is done.
Yeah. So we're just like trying to add more tools to make sure that so just like to add more tools so that we get a very, very detailed prompt. Like for example, we are trying to get information based on charts, the continent of Africa and things like that on charts. So yeah, we just like are trying to add more tools to it to make it, I don't know.
All right. Have you also tested the questions?
Yeah, we have also tested.
All right. So good progress on the first task. Oh, judging questions. Oh, you'll get them tomorrow.
Which is like 90% complete. You can be able to do the analysis, passing the CSV, and it generates the reports and everything on task 2. But on task 1, we are still struggling, lagging behind, but it's coming. It's coming.
All right. Anything else to add from members of team 2? All right.
We have much progress compared to yesterday. We've been able to generalize the RAG system to answer questions across multiple documents. We used different chunking techniques. The only issue we had was extracting the tables. Extracting table data from the PDF. But we are considering a more granular approach using computer vision to extract more than the tables, also include the graphs.
And also, you can also consider the techniques shared.
Right. But for task 2, no report at the moment.
No report at the moment. You want to talk?
Yeah, so for task 2, I think we've managed to interact with the CSV and at least understand the kind of data we are dealing with. So yes, that's our current progress with task 2, but we're still working on it. Yeah, and yeah, as he said, for task 1, we actually tried to query our system using with some data from the tabular data, and we realized that there is need for improvement, and that's why we shifted to focus more on like chunking the tabular data. Yeah, so I think whatever the approach that Eric has suggested could work for us, because that is our main challenge right now with task 1. Yeah.
Okay.
Which one?
Fumble concept.
Do you love soccer?
Yeah?
Do you love soccer?
I'm a bit the moderator. Not so much, but I'm an Arsenal fan.
What do you think? Is fumble a good thing or a bad thing?
Fumble?
Yeah.
I don't think it's either bad or
What?
it's more being
Yeah, so that's where we are. So, well, the fumble for our case is not the bad thing, it's actually the acronym. So it's self-defined. So our team, we actually split into two. So we are having an interesting day. Interesting has been used here intentionally. Yeah? Remember, until the end of yesterday, we were doing well, very, very well. So today it's an interesting day. We are facing our fears, that's the F. We are unstruck, that's the U. What would be the M? Yeah? What would be the M? I'll leave that to you, but we are bold. And we have standard leadership here. We have a team that is working on the second task and one that is working on the first task. Yep. For the first task, we are dealing with retrieval issues, but we are getting somewhere, so we are not giving up. And then for the second task, we've already set up our codes, and we've tried it, so we are very busy. So please go away. We don't have time for you.
All right, let's see if we'll have something tomorrow, yeah? But I hope everything is okay.
We have a base model for task 1. It gives out responses almost similar to the ones in the provided questions. And then, yeah, we're only handling the text, so we haven't done the images and the tables. My colleague, my team member here, she's working on that. The one that has just been presented here for the images and tables. And then we've got the other team, the other group of our team is working. They are working on task 2.
Task 2.
Yes.
And maybe they can share
No,
any challenges with us.
they are just starting to draw up the process of how they are going to undertake the task 2.
All right.
Yes.
Awesome. Any group which wants to add something to the conversation? Questions, open challenges to other teams? All right. And also when you go to conferences, count Africans, if you go to these international machine learning conferences, in Africa, and they're like, we brought it in Africa because more and more Africans teach it. But you know, even in that case, it's a history. Yeah, I think it's just culture. Yeah, you say that the only people who could benefit from that kind of side. Yeah. It's kind of just in academic. It's very academic, yes. Remote doing But
you're not coming to the office to say hi?
Yeah. Not really.
Hi, this guy is just standing for 10 years and told me what you want to do.
Okay, but pronunciation in the next 15. Yes. Okay. Yeah.
Fixing something in 5 minutes. You should
5 minutes. Yeah. So this hair was originally, was originally yes. So these are the guys who actually took the CC app.
But then is it being run here? Is the staff based here?
Yeah, he's a staff.
So it's what? It's a co-share-based innovation?
Yes.
Is it like an incubator funding?
Yeah, what I've heard is they are still struggling to see what they can do with it. So far what they have is some co-working spaces, but they're trying to still figure out what do they want to do. You know, the higher by you was mostly an ecosystem of strategy developers. But since it was bought, it has not yet. I've not seen the direction they're trying to take. Yeah, just for all kinds of talents, creatives, technologies. Yeah, and then this co-working space you can even rent it. If you are a remote worker, you can always work here. Open discussion, yeah. I love it. Just contribute it.
Yeah, probably to that discussion.
Yeah, absolutely. So who's leading?
So I can start presenting.
Okay, present.
Like 5 days talking about it, right? But then we'll do that discussion for that presentation. So you're just deciding what we're doing with this session. We don't know.
Starts laughing.
Oh, good. Judy. Oh, good. Judy, you're planning.
You're meeting for the first time.
I know it's Chris. Oh, good. Oh, wonderful. Could you give me last us to be? Not a thing. You just like the session right now. Concepts that come out is what is changed of what they're different. I can hold them
Let me just find
I can talk.
And then you can talk about L, you can talk about from data, just been thinking very slowly about
Great. We're all in this.
You can tell us about the US. Una model ya kufanya embedding na then kuna model ya design. You should
interesting. Okay, yeah, sure. Yeah. So should I need to present the work again? No, you don't need to present. Then just be like questions. We'll ask for like your perspective.
Sure, yeah. Sounds great.
That's it.
Okay, sure, yeah.
Thank you.
No worries. Yeah. Also, like, is it now?
So, 6:45, so in 5 minutes.
Okay, okay. I also have a question about, like, so we have some.
So this one has been husband. But you cannot say this.
Sawa, iko sawa.
Na presentation ingine?
Eh?
Na presentation ingine?
Ni kuna custom round table. Tunataka kufanya. Yeah?
Yeah, I'm learning a lot. You want people to keep quiet.
Niambia ni lakini hata nitaongea kuhusu nini tena.
Unauliza maswali?
Eh? Policy guardrails and alignment. Hey.
the way we've set this session up is I've literally just got one slide to help us think through something that's really important on when we think through any application for what we're doing, right? And that's data sets. So I remember yesterday when we started this hackathon, there was this discussion around the different organizations that provided their data sets, and I happen to be from one of those organizations, the Science for Africa Foundation, where I lead our policy portfolio. And so we really want to have this discussion about what is the link between policy? I know people think that's the government's job. It might be. I don't know. Let's have that conversation. Funding, our engineers, our researchers, people doing ethics. So what's the role and responsibility of each one of us in this room to drive the impact and the innovation that we want, right? So just to frame our thinking, right? I'd like to point out that, policy frameworks are very closely linked to what we call guardrails. And I'm sure, you guys can explain guardrails much better than I can. But the reason I bring up policy frameworks is that I know that Kenya is very famous from our last visit in Addis Ababa at the Africa Union Summit for different reasons. So the Africa Union actually launched its science, technology, and innovation policy and strategy for Africa for the next 10 years. And at the center of this strategy was how do we drive innovation, in particularly how do we build the AI ecosystem, right? And how do we get engagement from different players to actually influence this. And the reason I'm telling you this is that it's not something abstract. The next steps to this is all our countries, right? All 55 Africa Union member states will actually, come back to our countries and start building policies of how we want to work within this industry, right? So do we want, for Kenya, would we want to focus on climate? Would we want to focus on health? Is our government going to put local funding or national funding? Are we going to have tax cuts or not to enable this, right? And that's a discussion that takes everybody's voices, and that's something, at the SFA Foundation is one of our central philosophies. It's about co-creation, co-creating the solutions and co-creating and understanding the problems, right? So just to give you a quick example of this link, so we know STISA is coming for the African continent. We know it's got to focus on AI. We know our countries are going to come and put in regulations that will affect how we all operate within what we want to do, right? So the question is, why can't we just borrow from what already exists, right? And my simple answer is that we have very unique challenges and opportunities in Africa, right? And I know I'll give, is there someone who can pass the mic around for me? I'll give you one unique opportunity we have, right? Is the great minds in this room, right? It's our youth dividend, right? So how can we design something that captures this? But there are also other opportunities. Does anybody want to add to what other opportunities they think there are or gaps? Anyone, just speak up.
One opportunity we have is a very young and robust population.
Okay, population. Anyone else? Come on.
I would say there is opportunity in rural areas that are underdeveloped.
Yes. Yep. Okay, our rural areas. That's really interesting because that's a really important framework that why we can't borrow from what exists, right? Our rural populations and infrastructure is very different. Anyone else?
I see poor form of leadership, which drags most of the development behind.
Okay, leadership. That's another one. These are all right. I mean, there's no right and wrong. Anybody else? We haven't heard from Team 6. They're very quiet. Team number 6.
Team 6.
Team 6. Let's hear from you guys. What do you think is unique for us, or an opportunity or gap?
We are not quiet. We are thinking.
Ah, I like that.
So it feels like most of the things people have spoken to, we can identify the challenges.
Yeah.
So when you speak about a young demography, with some of my colleagues out there, we were actually thinking the dangers of being a Gen Z, and we spoke so much. No offense, Gen Zs in the room. Yeah, but they stand between opportunities and challenges. So I would only say maybe this is too fast to start speaking about the challenges, but what we've spoken at as opportunities can easily flip to become challenges that deny us, or, yeah.
Okay, so that's, thank you for that. You've just done my job for me. Thank you. So another real opportunity or gap, right, that we really need to think about is data, right? So who's generating the data? Where are we getting access to this data? Is that data accurate? Is it accessible to our engineers, to our software engineers, to whoever wants it? What is that story with data, and how do we collectively in this room want to inform the next policy on Kenya on data and innovation, right? So for that, the way I've set it up, I'm going to ask a few people. I'm going to pick the first 3 speakers to just come take their seat and just give us, a quick, I was told 10 seconds is too little, so take between 10 and 12 seconds to just quickly give us your reflection on why data in the African context is important for what we are trying to do. So please, I encourage, anybody from the floor to come. This is your forum, and if you disagree with somebody, please come tap them on the shoulder and, let them know what your response is. This is really a conversation. There are no right answers, there are no wrong answers. We are really trying to understand. So with that, I think first I'll pick on one of our main organizers, Geoffrey, if you can come. And then I'll pick on my boss. It's not often I get to do that. So Dr. Judy Omumbo, if you can join us here for a quick 10 seconds. And I think I'll put James on the spot, because James, you were meant to be co-leading this session. So those are my first 3 speakers, and then you guys feel free to elect the next 3. So 10 seconds, guys, on your thoughts, and then we'll have the next batch come.
Okay, thanks, Isma. So, AI. So, I guess some of you, not all of you, but I guess a lot of you are working on solutions, right, and innovations for certain problems, whether that's in agriculture or healthcare or different sectors. So I think an important thing to think about is, in order for those solutions that use generative AI, whether it's a chatbot or something, to provide some kind of guidance towards someone who doesn't have technical experience. An example being maybe farmers who are looking to access information on agricultural health or when to plant crops or that kind of thing. If that data is going to be useful, it has to be relevant to that specific context and that location. And so I think one of the challenges is, how do you, especially with these large language models that are trained on very, very large quantities of data, potentially at a global scale, is how do you make sure that they're able to provide the correct answer to somebody who lives in a very localized environment with its own set of other factors as well. And that becomes a data issue, because in order to be able to, for models to be able to think across scales like that, you have to have good quality data at different scales. And so not having that data and having gaps in that data, which is a problem not just in Africa, in all parts of the world, means that the models need to be able to account for that and still be able to provide useful insight.
Do we want him to keep speaking, or do we want to go to the next speaker? If we don't like something somebody is saying, we can, be Kenyan and say, okay, next. No? All right. Dave, we go to Geoffrey.
I think for me, I worry a lot about the fundamental limits of data, and that often we don't think that, data is a representation of the real world, right? But data is not the real world. And this is very problematic because, you know, the real world is a physical world, and in a physical world, all physical objects obey certain laws. All of those laws are not applicable in the virtual world, right? So if you take a simple one, light, gravity, these are concepts, right, that are very fundamental to the way the world we know operates. These concepts are not explicitly incorporated in data. So for example, you can say that when you have a video, right, of a pendulum swinging, that the swing of the pendulum in the video reflects, like, you know, the physics of movement, right? So you can estimate like the motion of that pendulum based on some physical equations, even when it is on a video, right? But the difference is that in the video, when you decide to perturb the pendulum, right, the pendulum will not follow those laws of physics. But when you perturb that pendulum in the real world, the physics will be different. So this fundamental limit of data means that whatever we do with data, we should always remember that data is not the whole story, right? There's always a part of the story that we miss. And for me, I think, especially being a scientist, and one of the things I'm excited about is that we need also to think about how to represent the real world into the digital form. So let's not jump into the data, right? Let's start by understanding the real world. And if you're looking at data, try to understand where did this data come from, because this is part of understanding what is missing in the data that is actually important in the real world. Because once that missing thing goes into the digital world, then it's forgotten, right? Yeah, and I'm not sure that's the world we want, because we are physical beings, and will always be, even with robots, right?
I'm glad that you mentioned the real world. I come from the real world and really work a lot with data. My background is actually epidemiology, a field of medicine that actually studies diseases at the population level. And it's so important to know what's happening at the population level with diseases. But one thing I wanted to start off before I make my intervention around data is the issue about ownership. I don't know whether all of you have seen this map that you can produce from Google saying, what is Googled the most in Africa? And you'll be horrified. You know, you see, it's mostly football players or influencers who have a bad reputation, Uganda, for example. And you see the most Googled thing across the continent tends to be that, and they're not even African players. So as a continent, we need to really step up and provide transformative information. We do not have any transformative information on the internet. We don't have people speaking from a point of knowledge, and therefore data are really important and how we put that together. So in my sector, in the health sector, data is about who falls sick and where do medicines need to go. We have massive databases that every Ministry of Health has across the continent called the Demographic and Health Information System. No, it's the District Health Information System, the DHIS. The DHIS is owned by the powers who have decided they're not funding Africa anymore. All of our health data collected over the past 30 years is gone. So we need to think seriously about ownership and developing systems where we really think through what data we're collecting. That word, by the way, is just used very lightly. Somebody can take a bunch of photographs, all those megabytes, they call that's data. You know, we never think about things of how it's curated, what are the metadata, do we understand where it's coming from? Jeffrey has told us about what does it represent. So basically, coming from the health sector and working in the intersection between climate and health, we've always felt the challenge that the health data are collected as data points that have nothing to do with each other. We go to a hospital, we collect information at Kenyatta National Hospital for people who have come from Eastern Province, Central Province, Western Province. They've all come. We measure the end point. We don't measure their experience of where they were exposed to the disease. How long did that happen? So now when you're trying to match these data to understand what's happening with other biological systems, the environment, for example, which is a potent area for us, we cannot relate what we see in the hospital to what has been experienced in the environment. Simply because today, maybe I traveled to the coast and I went to a place where there's malaria, I caught malaria. 14 days later is when the symptoms show up, and I go to the Aga Khan Hospital because, you know, I'm one of the people who have achieved all of their sustainable development goals. I go to the Aga Khan Hospital, they're diagnosed with malaria, and the only record is Judy came in with malaria. Does that tell you anything? I didn't catch it in Nairobi. They don't write when it came from. There's no connection to the earth. Everything about our lives is connected to the earth. We cannot match those data, even the one that has gone with USAID, with anything in the real world. It's a massive challenge. So for me, the interest on how we can use these systems to develop better ways of measuring health, that we're looking at health and not disease and death, because they're two different things. Malaria is not health. Malaria is ill health. Schistosomiasis is not health. It's ill health. And then we're also looking at now the trend in diseases across Africa are more what we call the non-communicable diseases, the stroke, the diabetes. These are all things that are related to lifestyle. And lifestyle has an environmental component. Can we look at better databases that measure the environment, the ecosystem in which we live to define our health, rather than what do they call, the tips of the curve? Because the tips of the iceberg are where you start counting the death and the disease and so on. So we really do think, you know, AI is coming in a wave. Can we ride that wave intelligently so that we're not busy running around doing all sorts of things that are not connected to the earth that we're all connected to? So really help work with the sectors to think through what's the best way to do it. I always use the climate sector as a very good model because they have mainstreamed the way of collecting information. They identify a spot, repeated measurements in the same spot for many, many, many years. You cannot say anything about anybody's experience without measuring them repeatedly from the time of birth. Did you get all your childhood vaccinations, for example? Did you live in a place where you were exposed to something like seizures from certain diseases? Seizures in children under the age of 5 always cause something in the brain. Later on, your development of things like dementia can be impacted by things that happen to you as a child. So can we look at better ways of looking at the exposure related to environment and where people live? Really integrated databases that you, the next generation, are going to help us develop.
Okay, so I'm thinking of this lady in Kilifi who does not have any trust of the lady who studied midwifery at the University of Nairobi and does not have a child and has to take her through the birthing process. And because she doesn't have trust, she decides to work with a traditional midwife back in the village, because for her what really matters is that she gives birth, and she's giving birth through the support of somebody she trusts. And then that goes unreported. And so we don't know how many children were born. We don't know whether their mothers are safe or they died. And so we have issues of underreporting of data, whether it is mental health because of stigma. If I go and say I have ADHD, every other African will look at me and wonder, what is wrong with you? Why are you looking for attention? And that goes underreported or not reported altogether, like aggregatively. Well, because of stigma, for example, or because of convenience of trust of the system, it still goes underreported. I don't know what we can do about data underreporting. So as we think about ownership, we also have to think of how we're going to consolidate all this information so that if somebody dies and the verbal autopsy is that this person died out of witchcraft, it's recorded as so and not out of heart attack. Yes, because I think, and you'll agree with me or disagree with me, the only one thing that cannot be funded, but it's very important to study, and I personally cannot dare to study, is witchcraft. But we speak about it in Africa. It's an African problem, right? Thank you.
Is it real?
Okay, thank you very much. Maybe we do face is the insufficiency of data. The little data that we have is not well structured in a way that is consumable, especially in the global south, specifically Africa. So one of the things we're trying to do from the company I work for, it's DataWise Africa, we're trying to make this data in a way that is very much presentable and consumable ready. Because one of the problems you were facing the other day is just getting a list of hospitals in Kenya and knowing maybe which levels they are, how many beds do they have. Finding that simple data is a problem. And so where do we get the data sets for example? How are they stored? And another thing that you are maybe having issues with is the recognition of the dataset creators. Maybe that could contribute to why we don't have enough dataset, because you may be putting more effort in creating the data, but as soon as it goes outside there, nobody ever knows whether you're the one who created it or not. So again, on the same, we're trying to find solutions on that. But so basically, when you asked about opportunities and challenges, these are the things that were crossing my mind. Like we have dataset insufficiency, but what are we doing to really make the dataset be present, be there, and it's in a very consumable format?
Thank you so much. So I forgot to mention that I'm actually timing you guys. That first batch was our leadership. Let's have your answers in 1 minute. And the reason is obviously we want to hear from as many people. And I've always heard this concept, if you can't say something in 1 minute, we're not going to convince anybody. So literally your elevator pitch in 1 minute. Whoever wants to start first.
I could go. This is convenient because I don't have a lot to say. Everyone here is talking about data, and data is super important, super cool. Keep up the data talk. But when you talk about data science, we're all data scientists here. A lot of it is what you do with the data. So I just wanted to shed some light on, it's really important not just to collect the data, but to do the right thing, and that's really important, especially when you're talking about policy. I wrote half of my entire PhD thesis on how people in some parks in America, they were collecting the best data in the world on managing the system, but they were managing it terribly because they didn't know what they were doing with the data. And it made it a really easy thesis for me where I was able to be like, you guys are dumb. But just collecting the data isn't enough. You have to be smart data scientists and do the right thing with the data. So that's my 1 minute elevator pitch.
Thank you. Do the right thing. Okay, I like that.
I come from pharmacy, so just thinking a lot about obviously the missing data among different populations, geographic obviously, and also age and gender, and just thinking about how that's not that's not advertised in medicine. How are these outcomes of this medicine tested? And so I think that's a really germane thing to think about. And a mentor once said to me that, with medicine, kind of with what I showed, that we have the tools of Star Wars and Star Trek, but with the public health aspect, it's more like the Flintstones. And I don't know if these are cultural references that you guys are familiar with, but it's just the invention of medicine can be accelerated so much, but then the actual implementation, to the woman who just said about trust, right, about having the right deployment, and so that you'll actually have the meaningful outcome, I think is really important to think about. And I just keep thinking about the comment of everything is connected to the earth and nature-based solutions, I'm hopeful that one day we can get to that public health outcome where we recognize that the loss of trees kind of gives an uptick in stroke and heart attack because of the ecosystem service that these deploy. Even though we have good medicine we don't have good medicine yet for stroke, but one day we will. But I think that just keeping trees around the ecosystem is an important component, and so I'll leave it there.
Okay. We're up by 3 seconds, but that's fine.
All right, here we go. So yeah, I was gonna first start with just echoing the other comments that have been made about collecting good data and ownership of that data and encouraging more of it, because when you have gaps in data, someone somewhere is going to be making assumptions about what's going on in places like this beautiful country that we live in. And so if you're not advocating for better data, those gaps will be filled, and you have to have the you have to be empowered to be able to show that that's not right or it is right, and you do that with the data. Data is power. So I'm a vet, and I'm working in One Health epidemiology. So you end up working with a lot of different people across sectors, the so-called interdisciplinary research. And you find that a lot of people know a lot of different things, and we have a lot of information. So while we complain about not having data, at the same time there's a ton of data. And so you guys can really bring it all together and be the true sort of ones that make interdisciplinary research work by organizing that data. And so I've gone over. But I really do feel like data scientists have such a role in helping us organize what's going on in different fields and bring the sectors together and then present it in a beautiful way that makes sense.
Especially for these kind of solutions we're trying to create. So someone at Kisii, rural Kisii, is he able to assess that premium service? Because doing AI is expensive. Whatever we create is also expensive. It's very expensive to run these queries using GPU resources. So pricing barriers are very significant in our African context, not only for the end user, but also as well as for implementers, the machine learning engineers here. So how many of you can afford to actually pay the ChatGPT subscription? So it's priced for the European market and not for our African. We find it very expensive. We are only looking for free resources for us to be able to push our research. So this is very significant. And the only way to bridge this is partnerships for fundraising, as well as trying to see if you can also be able to create solutions which, at the end of the day, are low cost to our end users.
Okay, great, thank you. So, any challenges, any additions? There's a challenge.
If it's mentioned
our previous
before.
speakers, if we can just make space for the next contestants to have the space on stage.
As to how many languages we are covering. I think a lot of languages in Africa and also a lot of different countries in the world are not represented enough in LLM training right now. And so LLMs tend to be more like weird, Western, educational, industrialized, rich, and democratic. So we want these models to also be more, non-weird and also cater to different populations, because a lot of the times in rural areas, people only tend to, not understand English all the time. So we would want to develop models that actually can cater to all of these, and also consider like different modes like speech, images, etc., which can definitely help with the text data. Yeah.
So just something. So mine was more of a question, and I thought some of the panelists could answer, but I think now I'm in the panel, so I'm not sure what should happen.
You can ask, and then if we have time, we'll come back.
Yeah, so I just have a general question. So we have all this, even in the presentation, it was mentioned that we have all these tools and frameworks, and they're very exciting, and also can be a bit overwhelming. But then we get a solution like the one we were shown just a few minutes ago, that's just using good old Python. So we're a bit curious. So my question was generally, at what point do this
Okay, so I've noted that, and I will ask someone to respond. We go our last speaker.
Was funding. Unfortunately, those who are funding have no the background you have. So if today you were to go and ask that the Parliament or the Treasury of Kenya should fund the committee to have here, the data scientists, which evidence do we have that data scientists could drive an impact in the society? So 2 weeks back, I was in the Parliament trying to basically, argue for a case for funding for research. But even if there are needs, or maybe you can maybe give some evidence, some the question comes back, which evidence do you have locally? So if you go back during the COVID, the government used the executive order through the president. It's because we do not have evidence supporting any other measure to be taken. So we need to have the evidence that basically speaks to the needs of the community that we are basically working with. And even your case, trying to argue that we need support, even for like where I come from, working in the Ministry of Health, we don't have the data scientists there. So how do we argue that we need one? Okay. Which evidence do you have that you're important in the society? So as we try to add for other data, so trying to provide any other data, so start from your own needs and why you think you're important in the society.
Great, thank you. Any right? So I just want to quickly summarize what we've heard, right? So the challenge we put forward was, why is data important for what we're doing? And, how do we start thinking through this data? And my challenge to you is as you develop your solutions, time to myself. As you develop your tools for this challenge, for this hackathon and innovation, right? When it comes to the data sets we've given you, a few things that have come up. And, some will be important as you design today and tomorrow, and some as we move forward, right? So the big one is, think through the gaps, right? Then how do we link real world with the data? So the contextualization of data. Representation. So whether that's gender, or whether it's the innovator in the room that's making policy, or whether it's representation from climate data influencing health outcome. Trust is a very big one, and I want to thank you for bringing that up. Partnerships, right? How do we partner? Who are you partnering with? What does your team look like? Then the big one is obviously around funding and influencing policy. And I'm really glad to have had this conversation, because at the SFA Foundation, right, these are really core pillars of what we do. We co-create with different partners, we design on the need, we identify the needs, whether there are gaps in data, and then mobilize funding around it. But not only that, then we drive impact by really having these conversations around how do we engage, how do we communicate our science, how do we influence policymakers. So thank you all, and please consider these as we go through our challenges tomorrow. And then I will just quickly leave you with my closing thoughts, is that, the success of whatever we are doing here, especially within the Africa's health context and climate, right, is ultimately dependent not only just on the technology that we are building, but it's also in the implementation. And we'll only get it right if we put our people and our environments first. So thank you so much for being such great listeners, contributors, partners in this. And I think I will hand over to James. Oh, all right, thank you. Thanks,
thank you so much. There was a question by use frameworks versus when to just continue building your own code. So frameworks are very great, especially when you're trying to prototype and test different things. But in a production system, most of the times, especially if you're worried about latency or creating very lightweight code, it's always very good now you transform that framework into something which is going to work for you. But yeah, feel free to use them and prototype. How do you keep up? There are a lot of ways to keep up. There are Discord channels you can join. There are Twitter influencers you can follow. But there's a lot going on, definitely, and it's overwhelming. So this marks the end of day one. Day two, sorry. This marks the end of day two. So we meet tomorrow. Please, I know some of you are not going to sleep, but let's meet tomorrow, and we'll be very excited to see what you have been able to come up with. So thank you so much. James, anything to add?
Yeah, just maybe timings for tomorrow. So thanks everyone for another great day. So we're going to be judging from, is it 11? 11 a.m. tomorrow. So yeah, the sooner you get here, the more time you have to work on solutions. So you'll have time to work on them all the way through to judging. We'll be here to help you have a look at, how they're responding to questions, things like that. We'll have judging at 11, and then we'll have external guests from various different organizations coming in, and we'll expect each group to give a short flash talk just on your solutions, right? How long? Maybe, 5 minutes-ish. You can use slides if you want. If not, that's fine. Just to talk about your approach. Bear in mind there'll be a lot of people in the room who have no idea about what an LLM is beyond ChatGPT, so kind of keep it as user-friendly as possible. And then we'll do the judging, and then there'll be an award ceremony at about, I think, 1 o'clock. And then we'll be aiming to wrap at about 2. Any questions? We're all good. Cool. Okay. Well, thanks, everyone.
Thank you.